Hi guys, this video is a special video for us and you guys because this is the video we are posting at the second anniversary of Expert Tutor. We have launched Expert Tutor with the name of Learn Mathematics. Let's make mathematics easy on 3rd January 2020. However, we have reached 20,000 subscribers up to now. So this is a special video and we are going to give something special for you in this video also. So in this video, we are going to discuss 100 mechanics MCQs, MCQs with a detailed explanations. And if you have any doubts, you can leave it below. And the main thing is we are going to give 2 surprise news for you guys. The first thing is if this video reaches 1 million views, we are going to give a biggest giveaway from our expert tutor, and we will tell that reward later when it reaches 1 million views. And the next thing is in this video, in this section, we are going to ask some question, or we will leave some question for you, and you can try it in your own, and you should send the answer to that mail we have provided in the description. You will be rewarded, and this guy who has given the correct answer with correct step will be rewarded soon, and we will publish that guy in our videos too, in the upcoming videos too. So the main thing is we like to thank for your support for through the entire life of Expert Tutor. Okay, without wasting our further time, we can directly go to the 100 MCQs. Okay. So the main thing over here is when I'm searching for 100 MCQs, I got many papers, but here I have taken a paper from studiestoday.com. As the main thing is I have searched 100 mechanics MCQs and I get many papers. So this one is, I think this one is better. And the main thing is they have mentioned that this paper is mainly for NEET exam students, but the main thing is normally physics, mechanics won't change for syllabus. So any students can try this paper, and I have given the description in the link in the description of that studiestoday.com as well as the paper PDF link. So you can always download that and try it in your own. And the main thing is I have get this inspiration from Black Pen Red Pen channel. They have already posted many videos about 100 things. So I get that inspiration from them. This is new to me, so I'm not sure whether I can do 100 MCQs at a time. Let's try it. Okay. The main thing is please try it in your own. Download the paper and try it in your own. After that, watch the rest of the video. So it will be very useful for you guys. Please try it in your own first. Okay, the first question. The branch of physics dealing with motion without considering its causes as known as. So here, you need to know what's meant by physics. When we are considering the branch of physics, simply means that we are going to consider about mechanics in this case. So when we are considering about the mechanics, we can divide it into 2 main pieces. One is kinematics or kinematics, known as kinematics or kinematics. The next one is dynamics. So over here, we are going to consider kinematics or dynamics. We need to consider both, but they are asking about the motion without considering its causes. When we are studying about this, you need to know the kinematics part is dealing with the motion part without considering the causes. Actually, we knew that when we are considering about the motion, what would be the cause of those? Surely the forces as well as torques are the quotient of a motion. So here, when we are studying about the kinematics, we don't consider about that. But when we are studying about the dynamics, we will learn about that. The main difference between these 2 terms are kinematics or kinematics is dealing with motion without considering the causes, forces, and torques. When we are considering about the dynamics, we will consider about those things. So this is the main difference. So here they have asked about the motion without considering its causes. So when we are considering without considering its causes, is going to be kinematics. So the next question is, mechanics is a branch of physics. This branch is, so in the previous question, I have told about this. When we are considering about the mechanics, we are going to divide it into 2, mainly 2. one is kinematics and dynamics. So the another main thing is dynamics is also known as kinetics or kinetics. When I'm searching Quora.com, one has answered about this question. He has mentioned about the kinetics or kinetics. You need to ignore that MA from this kinematics. You will get the spelling of kinetics. So the kinetics is referred to as dynamics after the 20th century. Before the 20th century, the dynamics is called as kinetics. So that's a different, but the main thing is there are mainly two parts. Okay. The third question is to locate the position of the particle we need. Actually, we knew that it's a frame of reference. When we are considering a displacement, we can get that point, displacement, what we can figure the position of a point from many locations. When we are considering, let's say, actually I'm in Colombo now. Let's say there is 1,000 kilometer, the India is situated 1,000 kilometers away from Colombo. When I'm considering the position of India from Colombo, I'm going to get 1,000 kilometers away. So if I consider the India's location from America, it's going to be different. So the location of locate the position of a particle, we actually need a frame of reference. The frame of reference is simply known as the point we are choosing to measure the length from that point. So here in the previous example, I have mentioned the point of reference is going to be Colombo. In the second part, the point of reference is America. So these are then this is known as a frame of reference. Then locate the position of the particle we need to locate. We need a position. So that is known as a frame of reference. So in this next question, frame of reference is it's going to be place and the situation. So when we have, most of you have already studied about relative velocity. When we are studying about relative velocity, we are going to take a reference frame. So that reference frame can have a velocity. If it have a velocity, we need to use vector addition method to find what's the relative velocity of that object, another object. So the main thing is it has a place and a situation. So you can figure it out if you read all the three answers, all the other three answers. In the next question, they have given a diagram as shown in the figure. A particle moves from O, that's 0, so 0 to A, and then A to B. Find the path length and the displacement. So over here, they have asked about the particle is moving from 0 to A and A to B. So path length, what's meant by the path length is the total distance or total length. Let's say that's a human. So the total length worked by that human is known as path length. What's meant by the displacement is the shortest distance between initial position and last final position. As you can see over here, the person is walking from 0 to A. So we need to consider the distance between that 0 to A is going to be 3. You can see the points over there. So it's going to be 3. After that, he is going to return from A to B, which simply means he is going to walk through another 5 points, let's say 5 meters. So first of all, he has walked for 3 meters. After that, he is walking for 5 meters. So totally, he's going to walk for 8 meters. So that's known as path length, the total distance walked. Remember, like that. So total distance covered is known as path length. The next question is displacement. So what's the initial point over here? When we are considering the whole motion, he has gone for 0 to A to B. So in the initial position, he is in the position of 0. After that, he's going for B. So we need to figure the answer 0 to B. From the 0, we need to figure it out the B. So from the 0, it's going to be -2. When we are considering about the displacement of vector, you need to put the signs. So from the 0, the initial position, to final position is going to be 0 to B, the shortest distance as they have given in the line, in a line. You should know when you are having 2 points, the shortest distance between those 2 points would be a straight line between those 2 points. So you can tell in this question, they are directly tell there's a line. So you can directly tell it's going to be -2. Why is that? From 0 to B, it's in the negative side. Okay. So sixth question, a particle moves from A to B and then it moves from B to C. So here, A to B and B to C. Calculate the ratio between path length and displacement. What's meant by path length? I have already described, which simply means we need to take account from A to B, which is 10 meters. From that, we are going to move B to C. So it's going to be totally 20. It has walked through 20-meter path. So after that, we need to find the displacement too. What's the displacement? What's the initial point over here? A. What's the final position of that person? Is C. So actually, we knew 2 points, final and initial and final. The next thing over here is we need to find the shortest distance. Actually, I already told in the first question, the shortest distance would be a straight line between these 2 points. So if I consider the straight line, it's going to be 10 meters. They have already marked that. So it's going to be 10 meters. So this is the displacement. So if you are considering about the displacement, they haven't mentioned about the direction as well as anything. So you can directly tell the magnitude of that displacement is going to be 10. And we actually knew that the path length is going to be 20. So if they are asking about the ratio, so you need to divide the first one with the second one. So if you divide the 20 by the 10, you are going to get the answer of 2. So it's going to be the answer of A. A particle moves from A to B and then it moves from B to B, as shown in the figure. Find path length and displacement. So over here, they are asking about the same concept. The first one is we need to find what's the shortest length, that's known as displacement. So over here, it's going to move A to B and B to B. Actually, we knew what's the displacement. It's going to be E. So actually, they have given the answer in the L. So let's say this is L. So it's going to be L. So over here, the question is, actually, we knew the displacement, but we need to find what's the path length. For finding the path length, we need to know what's the distance of this and what's the distance of this. As they have given a rectangle, you can directly tell you need to use some basic geometry to find what's the length of it. So from that geometry, we can tell it's these lengths are going to be the same. So that's the main point. These lengths are going to be the same. So from that, I can directly tell we need to find any of these lengths. Also, they have given the 60 angle of this. So how we are going to use the 60? That's the question. If they are giving some data, you need to try to use those data. Otherwise, it will be a little bit difficult to find the answer direct. So if this is 60, we can tell this is going to be 120. If this is 120, what can you tell about this angle? It's going to be 30. As these two lengths are equal, PA and PB are equal, we can tell this is going to be 30. From that, as this is 30, the question is, we need to find the length of this one and this one. They are both the same. So if I draw a perpendicular line for this one, this is a right angle triangle. As these lengths are the same, PB and PA. If I draw a perpendicular line or a line from P to AB, it's going to divide those into equal position, equal parts, and it's going to divide at 90 degrees. So from that, we can predict it as this is this. We knew this angle, this is 30, and we knew this length. It's going to be L by 2. So this length would be, the PB would be, from that we can tell it's going to be L by 2 over cos 30. So I'm going to write it like this. So it's going to be L by 2 over cos 30. How I'm telling like this is, you can directly use the definition of cos angle. If you use the cos 30 from this, it's in this right triangle, it will return this one L by 2 over PB. So if I subject that PB, so PB is going to return PB is equals to L by 2 over cos 30. So if you simplify this, you will be getting, it's going to be root 3 by 2. We'll be getting L by root 3. But the question over here is, actually we need to use these two, AP and PB. Now we have found the PB only, but actually we knew that they both are same. So from that we can practically tell it's going to be 2L by root 3. That this distance would be, path length would be 2L by root 3. So if you refer to the answer, you can directly find this is going to be the answer. After that, you need to find the displacement. As I have already mentioned, the shortest distance between these 2 points is going to be L. So answer is A. Let's move to the next one. The car goes from one end to the other end of a semicircular path of diameter d. Find the ratio between path length and displacement. It's also a similar question. You can try it on your own too. So here over here, if I draw a semicircular path, so it's not a circle, don't. Okay, fine. So this is, let's say this is a semicircular path and they are given the diameter of d. So over here, we need to find the length and displacement. So the car is going from this through a semicircular path, it's going to go to this point. Let's say this is B. The shortest distance, the displacement we can directly tell is going to be D. However, how we are going to find the length of this one or path length of this? Actually, we knew that it's the half of the circumference of this circle. As they have already mentioned, it's a semicircular path. As the whole, for the whole circumference, we knew the equation is going to be 2 pi r. Some students learn like this. For the 2r, most students will use d, the diameter. So it's going to be pi d. So from this, we can tell the for whole circle is going to be, the circumference would be pi d. But here we only have a half circle, so we can tell it's going to be pi d by 2. But the question over here is, we need to find the ratio between length and the displacement. When we are considering about the ratio, we need to divide the displacement by, we need to divide this path length by its displacement. We already calculated the displacement is going to be t. So if I divide it by t, it's going to return the answer by pi by 2. So in this question, the main thing is, actually you need to know how to find the circumference of a circle. If you know that, you can directly find the answer about that. Okay, let's move to the next question. The particle goes from point A to B, its displacement is x, and path length is y. So they're asking about the ratios, x over y would be greater than or less than, or what's that? So that's the question. Okay, in the previous question also, you can figure it out. The displacement is the shortest length. Let's say this is a point A and this is a point B. If a man goes, what's the displacement of this? Actually, this line between these 2 points are there. This is the shortest distance according to the straight line. So this straight line is the shortest distance between these 2 points. However, let's say a man is walking through this straight line. So in this case, what would be the path length and the displacement? It's going to be the same. If a man is walking through the straight line, actually we knew that displacement is the same, as it's going to remain the same as A and B are short. We need to find the shortest point between A and B. Actually, we knew that the shortest distance can be found by using a straight line between those 2 points. So over here, this is the shortest length. If a man walking in this line, we can tell the path length is also be the shortest length, and it's going to be equals to displacement. So we can tell x is going to be equals to y. If x is equals to y, it's going to be 1. Let's say another man is coming and walking, let's say, in this path. So in this case, we can directly tell the length, the path length is going to be higher than the displacement. So we can directly tell y is going to be higher than the x. So from these 2 points, we can directly tell if the y is higher, the lower part is higher, what's going to be happen? We can directly tell the ratio would be lower than 1. If the y part is higher, we can directly tell it's going to be lower than 1. But the case here is sometimes it might be equal. So if they both are equal, we can directly tell x is equal to y, which the ratio will return the answer of 1. So from these 2 parts, we can tell that answer would be D. It should be less than or equals to 1. So you need to consider, or you need to imagine 2 points and derive the answer quickly. In the next question, as shown in the figure, the particle starts its motion from O to A, and then it moves from A to B. AB is an arc, find the path length. So over here, they are asking about path length. Actually, we knew what's meant by the path length. Path length is the total distance covered by that particle. So over here, from 0 to A, or O to A, actually, we knew what's meant by that O to A. It's the radius of that circle, of that arc. So we can tell the O to A, the distance between O to A is going to be R. So we actually knew the answer, the first part of that answer, it's going to be R. Plus, the next question is, we need to find what's the length of this AB. What's the length of it, AB? So the theory is, you can use this formula directly. It's going to be R into theta. It's going to return this length. R is the radius of that circle, and the theta is in the radius, and theta is this angle between this. You need to always use that angle theta in radians. If they given 30 degrees, you can't use it directly. You need to convert it to radius and only you can use this theta. So this is the answer, R plus R pi by 3. If you take common from R from these 2, you will be getting C. So over here, the main thing is you need to know how to find the arc. The arc would be equals to R theta. The main thing is when you are finding the theta, when you are substituting the value for theta, you need to use always the value in the radius. Okay. So let's move to the next question. Here is a cube made from 12 wires, each of length L. An ant goes from A to G through A, B, C, G. So the point they are asking about the calculate the displacement. Actually, when we are considering about the displacement, I already mentioned, when you are finding the displacement, you need to take only the initial point as well as the final point. So over here, you don't need to bother about these middle points. At the start, he is lying on here. That's an ant. Okay, in the final, it's going to have this point. It's going to move to that point. So what's the displacement? Actually, I have already mentioned, you need to find the straight line between those. So it's going to be in the, it's like a, okay, I am wrong. You need to imagine it in the 3D. So how to find this length? So that's a PS question. So the thing is, we need to use Binders Theorem. How are we going to use the Binders Theorem is, let's say if you consider this AH and HE is going to give an angle of 90. So actually we have found that there is a right angle triangle. But actually we knew what's the value of this, as it is a cube of having a length L. You can tell that EH is going to be L. Sorry, that's not E. I think it's going to be, that's going to be D. Sorry, D, E, F, G, G. Okay. So if I consider about that, it's going to be GH. The length of GH is going to be L. So the next question is, what's the length of AH? So how to find that? Most probably you will get the answer. How to find that? We need to consider another Binders theorem over here. We need to use another Binders theorem over here. As if we take this triangle over here, AEH, it's going to be L, and it's going to be L, and this is a right angle triangle. So we can directly tell, if you use the Binders theorem, you will be getting root 2L for this one. AH is going to be root 2L. Actually, we knew what's the value of HD. It's going to be L. So we need to get what's the point of A. That's G, I think. Yes, G. So H. Actually, we knew how to use the Binders theorem. We need to square it, and this we need to square it, and this also we need to square it. If I simplify this, I will be getting root 2 squared is 2, so 2 plus 1, 3L squared. If I find the root for finding the AG, I need to take a root in both sides. If I do so, I'll be getting root 3L. It's going to give a third answer, which is C. Hope I will be getting this clearly. If you have any doubts, please comment it below. I will try to give the explanation as soon as possible. So in the next question, as shown in the figure, particle P moves from A to B and particle Q moves from C to D. Displacement for P and Q. When they are asking about the displacement, don't consider the direction. They are asking about the magnitude. What's the line's length, like that, shortest length. They are not asking about the direction. When they are asking about the displacement, actually it means displacement means you need to mention about the direction too. However, in these questions, you can ignore the directions, and they are asking about the magnitude of these displacements. So when we are considering about the P and Q, X and Y respectively, P moves from A to B. Let's find what's the magnitude of the displacement A to B. So when we are considering about A to B, actually from the previous question also we are discussing about the shortest distance between these 2 points would be a straight line from A to B. So when we are considering about the straight line, how to find the length of this A to B? Actually, you already figured it out. So it's going to be this 2 and this is going to be 5. So we can directly use the Binders theorem. It's going to be 2 squared plus 5 squared, and we need to take the root of this one. It will return root of 5, 25, 29 is going to be returning a 29, root of 29. In the next part, they are asking about the Q moves from C to D. Let's say this is C and here is the D. If you connect these two, the X value is 3 and this is 4, you can directly tell CD is going to be 5, which simply means this is going to be root of 25. You can directly tell as 3, 4, and the Binders relation is going to return the answer of 5. So you can directly, it's going to be the 5, CD is going to be 5. But when you are comparing with the root of 29, it's easy if you take a root value for that. So when you are considering about the 5, it's going to be equal to root of 25. So from this, you can directly tell this is going to be large. They have mentioned that X and Y, P is A to B is X. So A to B, this is known as X and this is Y. So from this, we can directly tell X is larger than Y. So from that, you can directly tell it's going to return the answer of A. Yes, that's correct. The 13th question. Shape of the graph of position time given. So in the y-axis, we can directly tell that it's a dependent variable. In the y-axis, we actually drew a dependent variable. In the x-axis, we actually draw a independent variable, which means we want to control that. So over here, they have given it's going to be position. The dependent variable is position and the independent variable is time. In the figure, forward body shows that. So they are asking about the question, the body moves with a constant acceleration. Actually, some people might struggle about this question without seeing the axis. Here they have clearly mentioned about the axis in the x-axis, or in the y direction. They are marking the position or displacement. In the x-axis, they are marking the time. So over here, we can correctly tell the gradient is in the, there is a gradient, and the gradient of this graph is a constant and it's having a negative sign, which simply means it's having a velocity and it's in the negative side and it's a constant. So from this thing, you can correctly tell these three. So here the first one, they are asking about the constant acceleration. So in the first part, where we have told about, it's going to have the velocity, constant velocity, by looking at this graph's gradient. As the gradient, the displacement time graph's gradient will be equals to velocity. You can correctly tell velocity is going to be constant because of the gradient of this graph is constant. However, so that we can tell if the velocity is constant, we can tell the acceleration is going to be 0. So that's the main part. So, but they are asking about the acceleration is constant over here. Yes, it's 0, but it's constant. But the question over here is whether it's suitable. Is it the suitable answer for this one? So if there are any suitable answers than this one, we need to select that. It's a constant value. However, it's a 0 value. So in the next part, the body moves with 0 velocity. Actually, we knew that the acceleration is 0 and the body is having a velocity, negative sign. The body returns back towards the origin. Can you say that? So how to find that? So when you are considering about that, in the first part, in the first times, when the time is equal to 0, at the position from the, this is the position of that body. When the time goes, the position from the O is going to reduce. After that, it's going to, the displacement is going to be C. Actually, think about that, how we have drawn this graph. There will be a point, reference point called O. When we are seeing from this one, at the time is equal to 0, when I'm clicking the stopwatch, that person is over here. From this, there's a length, so that's the displacement. In the next, in some certain time interval, he has moved here. So the displacement is gradually reduced. So I have marking in this one. When the time is equals to, let's say T1, it's going to reduce. This is the displacement. Likewise, when at a certain time period, he is going to return for the same point. So that I have marked like this one. So from that, we can calculate the body returns back towards the origin. So this is the answer. It's going to be that. The point over here is in these 4 answers, the suitable answer, most suitable answer would be C. So the 14th question. The graph of position time shown in the figure for a particle is not possible because. In this question, the graph of position time shown. So they are asking about, they have given a graph. Actually, when we are considering about a graph, for a certain x value, dependent variable value, you can have only one independent value. Let's say for a time is equal to 2, there can be only one value of velocity or position. So from this, we can directly tell, if I consider a point over here, let's say this time interval, there are 2 displacements, whether it's suitable. It's like a miracle. If it's like a thing in a time, I'm living in here and I'm living in India too. How it's possible in 2 locations? It can't be possible at the time. Sometimes in the further they can invent any time machine and do that. So, but also the time can't be same and there can't be 2 locations for a person. So that's the main thing over here. So displacement cannot have 2 values at one time. So it, according to this point. graph. Also, in this case, they are also having two values of velocity in the same time. So it's not true for all the cases, but in this graph, there are two velocities. Let's say in this point, we need to draw a gradient to find the velocity. It's going to return the value of this. Here, it's going to return the value of this. So these both values, the gradient, are having two opposite signs, which means there are two velocities. It can't be happen according to laws. So the point over here is the 1 is also correct, 2 is also correct. What's about the acceleration? So when we are considering the acceleration, let's say when we are considering the gradient before this point and after this point is going to increase, the velocity is going to increase in the right direction. As the gradient is increasing in the plus positive direction, we can tell acceleration is going to be in the plus direction, in this direction. When I'm considering about this one, it's going to decrease, the velocity is going to decrease. So there's an acceleration. In the negative term, we can tell there's a deceleration. So there are two, they are masked about two different acceleration over that point. So over here, according to this graph, the three are possible. However, let's say there's a graph like this one, which are parallel to this. If they given a graph like this, you can't tell that velocity of a time in a time at the same time is different, because when we are considering about the gradient of these, it's going to be same at that point. So velocity is not going to be different, and the acceleration is 0. They both are same. So you can only tell displacement cannot have two values at one time. But here, these three can be possible according to this figure. So the correct answer would be A, B, C. An ant goes from P to Q on a circular path in 20-second radius. Radius OP. OP, they have given the length of OP radius. What is the average speed and average velocity of it? So when we are considering about the average velocity, average speed, we need to clearly know what's meant by that. The average speed is calculated by dividing the total distance by total time taken. When we are considering about the average velocity, we need to divide the total displacement by the time taken to reach that. However, let's see. When we are considering in this question, the particle is going to move from P to Q. There's a small mistake. I think it should be Q. So let's say through that arc circular path, it's going to move from P to Q. So in this question, we can directly tell the displacement would be the shortest length. So we can directly tell it's going to be from P to R. So there will be a straight line. So that is the shortest between these two. Actually, we knew that the person is going to walk around this. But when we are considering the average velocity, we need to take this length and divide it by 20 seconds. Some students might be thinking about this one and confused with this thing, because actually the man doesn't walk in that path, the straight line between PR. Then why are we considering this 20 seconds over here? That according to the definition, they have mentioned the average velocity is total displacement over total time taken on that process or on that walking period. So the total time, whether he has moved on this path or not, we need to take the shortest distance anyway. So that's the thing. So you need to divide it by the total time taken. Whether you can go in this side or this direction, the main thing is you need to take always the total displacement when you are calculating the average velocity. So that's the here definition, K-cut definition. So you need to know what's that. So over here, we need to find the average speed over here. So when you are considering the average speed, we need to find what's the length of PR. So when we are finding the PR, I have already mentioned it's going to be R theta. So here they have mentioned the theta in the degrees. So we need to change it to radius. So if I change this, I'm going to get, actually we knew that 360 degrees equals to 2 pi. So here the angle would be 2 pi by 3. 2 pi by 3. So after that, we need to multiply by r. They are given as 10. So it's going to be 20 pi over 30, 20 pi over 3. So this is the arc length PR, but we need to divide it by time. So if I divide it by 20, I'm going to get pi by 3 is the average speed of this. So if I consider the answers, yes, if I consider the answer, there are two answers. So we need to find what's the velocity, actual velocity of average velocity of it. So we need to find what's the length of it first. If I find this, we can directly tell the answer would be PR over time 20 seconds. So when we are considering about the PR, how to find it, this is going to be 10. And if I draw a line like this, as it's a two-side equal angle triangle, we can directly tell it will have an angle of 30. So this is, if it's 30, we can directly tell it's going to be 10 cos 30. If I take the 10 cos 30, it's going to return 5 root 3. This is a 5 root 3. If I consider PR, it's going to be 10 root 3. After that, I need to divide it by 20. The total time taken, 20. If I divide it by that 20, I'll be getting root 3 by 2, which will give the answer of B. So this is not a big question, but the thing is you need to know in the physics or in the mechanics part, mainly in the mechanics part, you need to know what's the definition is and you need to understand what it clearly means. Okay, let's move to the next one. 60. A particle is thrown in upward direction with initial velocity of 60 meters per second. Find average speed and average velocity after 10 seconds. So over here, this is also a little bit, you need to imagine and what's happening over here. So over here, they have mentioned about a particle we are going to throw in the upward direction with initial speed of 60 meters per second. So from this, let's say this is 60. After they are asking about after the 10 seconds. So when we are considering about this, actually we can directly mark like we can actually use the many equation for this. We can directly use the linear motion equation to find the answers. Let's try to figure it out using a diagram or image. So let's say I'm going to draw like this. So in the first second, it's going to reduce the velocity and the velocity is going to be 50 as they are given. The deceleration is going to be 10 as the gravitational acceleration. So in this case, if I throw upwards, it's going to be 50 after the time interval 1. In the next time interval 2, it's going to be, the velocity is going to be 40. Likewise, at the time 6, the velocity is going to be 0. After that, it's going to return over here. So after the 4 seconds, it will come to the same location where that ball, where that particle reached at 2 seconds time interval. So we can calculate, we need to find that this is the last position at t is equals to 10 seconds. We can calculate it's going to be in this point. So over here, we need to find what's the displacement of this, to find the average velocity. And the next question is average speed. So we need to find what's the distance between them. So we need to find what's the distance between them. So we need to find using the equations. So when I'm considering about, let's say I'm going to find this distance, how to find this distance? It's equals to the initial velocity, or in that other terms, we can calculate it's going to be equal to the path that particle moves in its initial 2 seconds. So from this, I'm going to use an equation. There are many equations, you can use any of those. So I need to have S, the displacement. So I'm going to use P squared is equal to U squared plus 2AS. Either you can use S is equals to UT plus half a T squared 2. So that's your wish. So those are the, you can use anything. In this case, you can use anything. So S is equal to UT plus half a T squared. So if I use the first one, ut plus half at squared, when I'm considering about the u, it's going to be 60. And the time interval, we can use either 10 or 2, as it will consider the displacement of it. Actually, we knew that at the 10 second and 2 seconds, it's going to be same. So we can directly use 10 or 2. However, I'm going to use the 2 to, it would be easy, I think, to substitute over here. So if I multiply this, I'm going to get 2 into 60, 120 plus half at squared. So when I'm considering the half at squared, a is 10, but remember it's going to have a minus sign over here, as I'm going to use this in the upward direction. As the acceleration, gravitational acceleration in the downward side, you need to put a negative sign when you are substituting for a gravitational acceleration. So you can tell it's going to be 5 into t squared. T squared is going to be, I'm going to substitute t squared as 420. So the distance would be 100. Hope I'm clear about this one. So u into t, let's check the time. 60 into 220 minus half into 5 into t squared. Okay, the answer is 100. So the distance between these 2 points is 100. So when I'm considering about this, actually we knew how long it has taken to come to that point. They have mentioned it has taken 10 seconds. So if I divide that, total displacement is 100, and if I divide this 100 by 10, we will be getting 10 meters per second. That's the average velocity. So when we are considering about the average speed, we need to find the total distance covered. How we are going to find? We need to find the total length of this, and we need to find the total length of this part. So how we are going to find? That's a question. So for finding this length, we can directly use this equation again, or you can use this equation again. That's your wish. In this time, I'm going to use this equation. Actually, in that point, we knew after the 6th second, we can directly tell the velocity, the final velocity. If I consider the point from the initial point to that, the velocity equals 0. The highest point is going to return the velocity of 0. So we can tell the final velocity is going to be 0, and u squared. So at the initial velocity is 60, u squared would be 3600 minus 2 into 10 as gravitational acceleration in the opposite side. So I need to put that minus 10 into s. If I simplify this, I'll be getting 180, I think 20, 22, 108. So the total distance is 180. So this is 180. So the question over here is how to find this one. Actually, you can use, at the time, you can use v squared from u squared is equal to s. From this point to this point, you can use that again. So, but the simple thing is, actually, we knew the distance 100. So from that, we can directly, it's going to be 80. So it's a common sense. You can directly use these things, these type of things, so you can find the answer easily. So over here you can get, it's going to return the total distance of 180 plus 80. It's going to return the value of 260. So from this 260, I'm going to divide it by 10, the total distance, divided by total time taken. It's going to return the value of 26. So from this, we can directly tell the answer is going to be B. Try to do these questions faster, because it's very easy. However, it might take some time. It might waste time sometime, as actually most of you can do this question very easily. I knew that. Okay. The ratio of path length and respective time interval. So they are asking about the ratio of the value of, we need to divide the path length with that time interval. What's mean by that? So here they have given that velocity and speed over here. Actually, I have already mentioned, when we are considering about the speed, we need to consider about the path length. If we are considering about the velocity, we can consider about the displacement. So over here, they are asking about the path length. The answer could going to be speed. But here they are asking about whether it's mean speed or instantaneous speed. So you need to find the answer for that. So over here, what's meant by the instantaneous speed? At that instant, what's the speed? Let's say it's about taking a limit on that. I think they have also provided that equation in the above. So over here they have you. The average speed is known as the mean speed is total distance by total time. They're asking about this. They're asking about the ratio between path length and the total time interval taken. So this is the equation. But what's meant by the instantaneous speed is we need to find the total distance. We can either tell that total distance. So it's going to be the difference between the distance and divided by difference between the time. And the main thing is when the time interval is 0, it's nearing to 0. That's why we are going to take the time delta t is equals delta t tends to 0. That's known as instantaneous. At that point, at that instant, what's the speed of that? So that's known as instantaneous speed. But in this question, they're asking about the ratio of path length and the respective time interval. So we can correctly tell it's going to be mean speed. The car moving over a straight path covers a distance x with a constant speed 10 meters per second. And then the same distance with constant speed of v2. If average speed of the car is 16 meters per second, then v2. So here we need to use the same equation over here. The car moving on over a straight path covers a distance x with constant speed. So it's moving on the constant speed and then the same distance with constant speed of 2. So in the first case, it's covering with the speed v. And the second case, it's going to cover it's by the average v2. And they are given the average speed. Actually, we knew that when we are considering about the average speed, what's the equation of that? Actually, you can't do without knowing this equation. Let's say I'm going to draw a diagram like this. Let's say this is A, this is B. Over here, it's going to have this 10 meters per second. Actually, we do know what's the value of this. Let's say this is B2. So over here, they have given the average velocity is 16, I think. Wait, I'll check again. Just 16. So over here, we need to find the equation. So here, let's take this is 16. The average speed, what's the equation of this is? Total distance covered by total time. What's mean by that total distance? So over here, they haven't mentioned about that. If they haven't mentioned, it's okay. Just name a variable. But I think in this question, they are meant to take this is x. So if they haven't mentioned, don't worry, guys. Take a variable name and put it over there, x. If this is x, we can tell what's the time interval taken from this point to this point when it's going at a velocity of 10. We can use x is equals to ut. So the time interval taken is going to be s over t, which simply means x by 10. This is the answer, x by 10. The time taken from A to B at the velocity of 10, at the speed of 10. When we are considering about this length, it's going to be the same, it's going to be x. But when I'm considering about the time, it's going to be x over v2. So this is a time taken from B to A, the time taken from B to A. So the question over here is we are going to substitute these values over here. X will be automatically cut down. So after we can derive the answer for V2. So the total distance would be 2x. Why is that? It's going to A to B, which is x, and it's going to return to A. So it's going total distance going to be 2x. After that, question is we need to divide it by total time. Actually, we knew the answer in the terms of x and v2. We can directly substitute over here. It's going to be x by 10 plus x by v2. So from this, I can directly tell we can cut down this x. So we need to simplify this a little bit. If I go simplify this, it's going to be 2. If I have a common over here, it's going to be v2 plus 10. And the denominator part would be 10v2. So if I bring it upward, it's going to be 10 V2. So after that, you can simplify this. You will be getting the value for the V2. So I'm not going to do that. Try it in your home. Okay. So then let's try the next question. That's also a little bit same. The bus travels between 2 points A and B. V1 and V2 are its average speed and average velocity. So over here, they are asking about the same question we have done relatively similar. Then we have found a ratio between X and Y, or displacement and distance. What's the ratio, whether it's greater than or lower than 1? We have found like that. It's a little bit similar to that. So here they are asking about the velocities, average speed and average velocity. When we are considering about the average speed and average velocity, actually we knew that the time taken for both are same. So we can tell we need to compare total distance and total displacement. So we are going to compare total distance and total displacement. So it's the direct question we have done in the question 3, I think. As the total time taken for these two measurements are same, we can directly consider about this one. Sorry, that's question 9. This one, X over Y. Actually, we know that displacement over path length or displacement over total distance would be less than or equal to 1. Either it can be less than or equal to 1. So likewise, we can directly tell it's going to be, so here, it can be the average speed can be equal. Otherwise, what happens? Total distance can be higher. So if the total distance is higher than the total displacement, we can tell the average speed is also going to be higher than the average velocity. As we can, that's the total time is 10. We are going to compare the total distance and the total displacement. If the total distance is higher than the total displacement, we can tell average speed is also higher than this average velocity. So either it can be V1 is greater than V2 or V1 can be equals to V2. It can't be less than V2. So B can't be the answer. Either it can A and C. So they haven't mentioned both answer in a single answer. So you can tell it's going to return the answer of D. It depends on the speed. Either it can be equal or it can be greater than V2. The car covers 1/3 part of the straight path with speed V1 and the rest with speed V2. What is its average speed? So over here, I'm going to leave this question for you guys. As I have mentioned, I will leave nearly 5 questions for you to try it in your own. So in this question, you are going to use the same theory we have used in question number 80. So if they haven't given any information or any distance, you need to take substitute a value for that. For here, I'm going to tell the answer in the next question. In the next other 4 questions, I won't be giving any clues for you. You need to try it on your own and send the steps to me via this email I have provided in the description, and you will be get a lucky prize if you get selected for those. If you corrected answers, if your answers are correct. Okay, over here, I'm going to give an idea. The car covers 1/3 part of its straight path. So there is a path and the 1/3. So actually we knew that if that there's a 1/3 path, actually we don't know what's the distance between 1/3. So you can directly take a variable name. Let's say that's X. So if that 1/3 is X, the next part that's going to be the 2/3. So if this is X, we can directly tell it's going to be 2X. So after that, there is a X and 2X. The X part is covered by the velocity of speed V1, and the rest part is going to, the 2X part is going to cover with the speed of V2. From these two, you need to take the average speed. You need to take when you are finding the average speed, you need to take what's the total distance between there. That's 3X. And you need to divide it by total time. You need to follow the same steps. So I'm not going to repeat it. Please try it on your own and try to send the correct answer with the correct methods and try to win that prize. Okay. The next question. Rohit completes a semicircular path of radius r in 10 seconds. Calculate the average speed and average velocity of it. It's a similar question we have already done. Rohit completes a semicircular path. So he is going to complete a semicircular path like this one. Always, I'm not good at drawing. Okay. So semicircular path of radius r. So we can mark it like this is 20. The diameter is going to be 20. Calculate the average speed and average velocity. When we are considering the average speed, we need to know what's the total distance. This is the total distance or total path length. So what's that? Actually, I have already mentioned it's going to be the total circumference of the circle would be pi d. So over here, we can tell it's going to be pi d by 2. So either we can tell it's going to be pi r. So they are given the answer in the r, so pi r. So we need to divide it by the total time taken. It's going to be 10 seconds. So it's going to give the answer of pi r by 10. That's the average speed. So when we are considering about the average velocity, so sorry, I have marked it as 20. It's going to be 2 hours. Okay. So it's going to be pi r by 10. The average speed is going to be pi r by 10. So over here, what's meant by the average velocity is total displacement. So over here, let's say the man is going from this point to this point. So we can directly tell he is going to move. The displacement about these 2 points is going to be 2r, the straight line between those 2 points. So it's going to be 2r. So if you divide the 2r by 10 seconds, it's going to be 2r by 10. So this would be the answer. So the final answer would be C. Hope you will be clear about this. Please try these questions in your own. These are simple questions. You can easily get correct for this rather than getting right for hard questions and getting wrong for easy question is very worst thing happening in the exam. So try to score marks in easy question. So the next question is, particle moves 4 meters in south direction, then it moves 3 meters in west direction. The time taken of particle 2 seconds, ratio to average speed, and so it's the same story, repeating. There's a Tamil movie called Marnadu. So there's a very powerful villain called S.J. Surya. The real name is S.J. Surya. They will tell that dialogue again. It will repeating all the time. So like that, it's going, the same concept is repeating. Okay. So over here, we can directly tell 4 meters. For that question, we need to mark a point. So let's say this is a point. The particle moves 4 meters in the south direction. So actually, I will always use that news for finding those south directions. This is going to be north, east, west. Okay, so we can tell this is going to be south. So after that, it's going to be 4 meters. So I'm going to mark that. Then it moves to west direction. So let's tell in EWS is going to be this direction, 3 meters. So the question is the time taken to by the particle is 2 seconds. So they are given the total time taken, it's going to be 2 seconds. What's the ratio between average speed and average velocity? So over here, the average speed, as I already mentioned, total distance by total time, the total distance would be 4 plus 3 is going to be 7. You need to divide it by 7 by the 2. It's going to be 7 by 2. We need to divide it by the average velocity as they are asked about the ratio between them. So when we are considering about the average velocity, first of all, we need to know what's the displacement of these 2 points. So in the initial, we are in this position A and in the last position B. So the displacement would be 5. So we can calculate it's going to be 5 by 2. So it's the answer is going to be 7 by 5. It's going to be 7 by 5. Okay. 23rd. The particle is projected vertically upwards with velocity 30 meters per second. Find the ratio average speed and instantaneous velocity after 6 seconds. So a particle is projected vertically upwards with velocity 30 meters per second minus 1. So over here we need to, they have given about the velocity. they're asking about after the 6 second. What happened after this 6 second? So over here, they're asking us little term difference, average speed and instantaneous velocity after 6 seconds. Why is that change? Have you noticed that? So over here, let's say what happened over here after the 6 seconds. If I'm throwing like this upward direction at 30 meters per second, actually in the at the first second, it's going to be 20. It's going to reduce over time, and at the third second, it's going to be 0. After that, it's going to return over here. We can directly tell once it came over here, it's going to be 6 seconds. So over here, if you find the average speed of this, you need to find total distance from this point to this point and this point to this point. So you need to find the total distance and divide it by 6 seconds. You can use v squared is equal to u squared plus 2as to find this distance. After that, you need to multiply by 2 to find the total distance. Is going to go to that path and going to return this path. So you need to find the total distance and divide it by 6 seconds. However, if you are finding about the average velocity or mean velocity, what would be that? So over here, you need to know the average velocity would be total displacement over total time. What's the total displacement about these 2 points? Actually, once we throw that, it's going to return to the same position. So from that, we can quickly tell these 2 points are the same. So the displacement is going to be 0. From that, the average velocity is going to be 0. That's why they're asking about the instantaneous velocity after 6 seconds. Instantaneous velocity means at the 6th second, what's the velocity? At the 6th second, what's the velocity? Actually, we knew that if we throw a ball like this 30, it's at the same point, it's going to return at the 30 at the opposite direction. We can directly tell at the instant of 6 seconds, at the 6th second, what's the velocity of this? It's going to be 30 in the downward direction. So it's going to be 30. So in the same way, you need to find the total average speed also. After you need to give the answer. So I'm not going to fully do that. You will be getting the answer of A, but I'm not sure about that. They have also given the answer in the last page. I'm going to give that for you too, but you can check with those. The 24th. The motion of a particle along a straight line is described by the function s is equals to 3t minus 2 squared. Calculate the acceleration after 10 seconds. So over here, they are asking about the motion of a particle along a straight line by the function. They have given a function with respect to t, what's the position or what's the displacement of a particle with respect to time. X is equals to 3t minus 2. So here, they are asking about the acceleration. We can directly tell when we are finding the acceleration, we need to find the velocity, the equation of velocity first. From the displacement, we can find the velocity by differentiating with respect to t. So I'm going to differentiate over time. Dx by dt is going to return. We need to differentiate 3t minus 2 whole thing squared. If I differentiate this, I'll be getting 2 into 3t minus 2 into 3. So I need to differentiate it. So here I'm getting the answer for velocity. Dx by dt is equal to velocity. If I differentiate that displacement with the respect to time, it's going to be dx over dt is equal to v. So another time, when we are calculating the acceleration, we need to divide it another time. So let's say this is v. If I differentiate this one, most probably you will know that when we are differentiating, we will, without writing d over dt, we can directly put v dot. So if I differentiate this, it's going to be 6 3t minus 2. So let's say this is going to be 6. And if I differentiate 3t minus 2 is going to be 0 as a constant value. If I differentiate 3t, it's going to return the value of 3, which simply means it's going to return the value of 8. So for, as you can see over here, the final acceleration part is not considering about the t. It's not having a value on t, which means it's not dependent on time, as it's a constant value. The acceleration is constant over here, so it's going to be 80. If they ask the velocity of 10, you need to substitute 10 for this t. If you substitute over here, you can get the velocity at the 10 second. So the question over here is, you are getting answer for acceleration, constant acceleration. So 25th question. Given figure shows a graph at acceleration time for a rectilinear motion. Find average acceleration in first 10 seconds. So over here, they are asking about the average acceleration. They are given the graph for acceleration versus time graph. So actually, we knew that what's meant by the average velocity. It simply means the total distance, sorry, total displacement over total time. Likewise, what's the meaning of average acceleration? Without knowing that, we can't do that. The average acceleration means the total velocity change over total time. So over here, we need to find what's the total velocity change first. After that, we need to divide it by the time. So that's a simple thing. First of all, we need to find total velocity change. For that, actually, we knew as the acceleration is 0, we can consider as this is starting from 0, or you can take the area of this. So we need to take the velocity change. You need to know the graph, the area taken by that graph with that time axis will be returning the answer of the total velocity change. So the first thing is they're asking about the average acceleration. The average acceleration equation is total velocity change. You can tell the velocity change over total time. So over here, when you are finding the velocity change, you can easily find using this graph by calculating this area. You need to know this part. Likewise, if you see the area from a graph from velocity versus time, the area would denote the displacement change. Likewise, in the acceleration time graph, you can tell the area of that graph with respect to time axis will give the velocity change. So I'm going to find the area of that. It will be returning the delta V velocity change. So for that, you can use the direct equation half into, if we take these parallel sides, it's going to return 10 plus 5 is going to 15 into the height is going to be 10. If I simplify this, I'll be getting 75. So this is 75. So over here, this is not a question. They're asking about the average acceleration. So we need to divide this delta with the velocity change by the total time taken. It's going to be 10. So we'll be getting 7.5. The answer is C. So be careful, be aware about these equations. Otherwise, it would be difficult to figure it out, these answers. Okay, let's move to the next one. So successfully, we have passed 25 questions over here. I'm very happy to do these 25 questions too. A little bit, I'm feeling a little bit tired. However, I hope, let's continue further. Okay. The body starts with motion with 0 velocity and its acceleration is 3 meters per second. So sorry, 3 meters per second squared. Find the distance traveled by it in 5th seconds. So body starts its motion with a 0 velocity. So if you have a question like this, try to draw or sketch a diagram. So it's starting on a motion like this, in a point like this, with a velocity v is equal to 0, as it's in a rest position over at the time 0. After that, is going to have an acceleration, and it's a constant acceleration. They are telling about the constant acceleration, which is 3 meters per second squared. So let's see. Oh, it's not a line. Okay. So they're asking about the total distance traveled by the 5th second. So over here, they are asking about the total distance covered in 5th second, which means they are not asking about the total distance covered. They are asking about the distance which have traveled in only that 5th second. So that's the point you need to know. They are not asking about the total distance covered in that 5 second. Total distance means you need to find all the thing. However, they are asking about the distance covered in that second only, 5th second, which means you need to find what's the value it have moved for 4 seconds. After that, you need to find the total distance covered in 5 seconds. After that, you need to deduct. If you deduct these two, you will be getting what's the distance covered in that 5th second. That's a method we are going to follow. So over here, there is a simplified equations, I think. However, I'm not going to use that. I don't know. I don't know what that equation is, but I remember there is an equation. Okay. So I'm not going to use that. Also over here, first of all, let's find this distance. How we are going to find is we are going to use either we can use any equation. It would be easy if you use s is equal to ut plus half t squared, as actually we knew what's the value of u, the initial velocity. They have already mentioned it's going to be u 0. So we can directly say s is equal to half t squared. We knew the value of a, which is 3, and we can directly substitute the t, which is 5 squared. So from that, we can directly find this answer. So if I simplify this, 5 is 25, 25, 35, 75 divided by 2 is going to be 37.5. Let's say I'm marking my paper. After that, the question is, we need to find the total distance covered in 4 seconds. So if we use this 4 here over here, I'll be getting over 16, 48, 24. So that the total distance will be 24. The total distance covered in those 4 seconds would be 24. From that, I'm going to deduct that 37.5. Sorry, I'm going to deduct that 24 from 37.5. The total distance in that 5 seconds is going to be 37.5. So here, that's the 2 points over here. So 37.5. But actually, I knew that within the 4 seconds, they have already passed 24 meters. So from that final part, the distance covered in this 5th second would be this length, which we can get it by deducting 24 from 37.5. We'll be getting C, which means 13.5. A body is moving in x direction with constant acceleration alpha. Find the differences of the displacement covered by in n second and n minus 1 second. So a body is moving in x direction with constant acceleration. It's like the same question we have done in the previous 26. However, here they are not giving the number values directly. They're asking in a variable's name. So here they are asking about the displacement covered by in n second. You can find in n second and n minus 1 second. So over here, they ask, it's like a previous question. The n second means you need to find the distance covered in that second, in n second. So that you need to use, you need to find what's the total distance covered in n. And after that, you need to find total distance covered in n minus 1. So over here, you can, I think you can directly use this equation s is equal to ut plus half t squared, but be careful. Here, they haven't mentioned about the initial velocity is 0. However, they haven't mentioned about the initial velocity. However, when you are deducting these two, the two displacement, that initial velocity part would be automatically cut down. Let's try that. So for that n second, I'm going to find that. Likewise, you need to find the n minus 1 second distance. After that, you need to find the difference. So when you are finding the difference, don't divide it by those two. You need to deduct these two. Okay, first find what's the distance covered in n seconds. So over here, I'm going to use what the total distance covered by in the n seconds. If I do so, I'll be getting it's going to be ut, let's say the initial velocity u Sorry, so when I'm considering the time t, it's going to be un plus half a alpha k squared n squared. So this is the total distance covered in that time n. I think I have made a mistake over here. You need to take the initial velocity at 0, otherwise you can't able to cut down this. I think, but, I don't think so, because we need to find the difference between those things. So let's do that. If you can't find this u, make it as 0. They should mention that. I think they have missed that part. Okay, let's find the final answer. If you have this u at the final answer, make it 0. So here, this is the total distance covered in n second, but here they are asking about the n second. So we need to deduct it using n minus 1 equation, which is equals to u into n minus 1 plus half alpha n minus 1 square. N minus 1 square. So the thing is, this is the answer you need to get for this one, n second distance. Likewise, you need to find the total distance covered in total distance covered in n minus 1 second. For that, you need to use this equation, but over here you need to put n minus 1, and here you need to use n minus 2. After that, you need to deduct from 1 to 1. So the thing over here is, I think you want there will be u if you don't substitute the 0 for that u. I'm not sure about that. We need to do some simplification over here. Let's try that now. So if I deduct over here, we'll be getting here minus u, so it's going to be u plus half alpha n squared. If I deduct from this one, so if I'm going to get half alpha n squared minus n minus 1 squared. So the thing over here is, you can directly find the next answer using this final answer, which means that you can find this n minus 1 second using this one. How to find this is, you can directly substitute n minus 1 for this n and n minus 2 for this n minus 1. So over here, if you substitute this, you will be getting u plus half alpha n minus 1 whole thing squared minus n minus 2 whole thing squared. I'm going to just substituting same thing, n minus 2 squared. If I deduct from 1 to this one, the good thing is you will be automatically cut down. So the question is perfectly right. So if you cut down, it's going to be perfectly right. It's going to cut down automatically. So when you are considering about this, you can take common of half alpha. If I take the common of half alpha, there will be n squared after deducting 2 n squared minus n minus 1 is going to already automatically cut down. If you deduct this one, it's going to be minus plus n minus 2 whole thing squared. So this is the simplified version. So you need to simplify this thing and we'll be getting this answer, but there's a little bit mistake over here, because they're asking about the displacement covered by n second and n minus 1 second. So when we are considering about the displacement, actually the dimensions of this alpha is not the dimension of displacement. So we need to have n squared in this answer. So if you simplify this, you will be getting the answer with respect to n squared into alpha. So that would be the final answer for you guys. So I hope you can simplify and get the answer, but I think the answer is a little bit wrong over here. If you find any other method, please drop it down in the comment section so I can also watch them. Sometimes I will make some mistake when I'm solving these things. Hope that's the idea of this question. Try it in your own. If you have any doubts, please comment it below. Or if you have any suggestions or any questions regarding this one, 27th, please drop it below. Okay, without wasting our time, let's move to the next one. What does the speedometer measure kept in motorbike? So that's a question. So what does that speedometer measure? So here, actually, we knew that when you are using a motorbike, you can directly measure the speed at each and every second. From that, we can tell it's going to return the value of instantaneous speed or instantaneous velocity. But the thing over here is it will use to measure the instantaneous speed because it won't calculate the velocity. It means when it's calculating the speed, it's going to measure how many distance or how far we have gone through that point or in that little bit of time interval, how far or how distance we have traveled on. So it's known as speed. So we can calculate it's going to return the value of instantaneous speed. The 29th. The displacement of a particle in x direction is given by x minus 5t minus 4 plus 40 squared. Find the velocity at time t is equal to 0. Before the thing over here is you can't find it by substituting the 0 in this equation directly. If you substitute, you'll be getting x is equal to 9. After that, you can't differentiate this equation and get the velocity. First of all, you need to differentiate this equation. If you differentiate it, the answer would be x dot is equals to x dot means the differentiation of x relative to time, which means it's equal to velocity. So the velocity would be equals to, as 9 is a constant, you can easily remove that. It's going to be minus 5 plus 80. So if I substitute 0 for t, the answer would be minus 5. So this is something very easy for you to handle. The freely falling particle covers a building 45 meters in 1 second. Find the height of the point from where the particle was released. So they are asking about, we need to find out what's the height of that. They are told that the freely falling means we are going to cover, we are going to leave that particle with the velocity of 0. So free falling means we are going to drop down without a velocity. We are not going to throw that ball. We are going to just release from that rest. So freely falling particle covers a building of 45 meter height in 1 second. So actually we knew that in 1 second. So in the first second, they are not telling about whether it's the first second or second second. Actually, we knew that it's going to cover the 45 meter in 1 second. Actually, we don't know whether it's in the first second or second second. So actually, we don't know about that. But we are, at the time we knew at a second it's going to cover a 45 meter. Actually, we don't know what's that. So we can tell that in the first second, what's the distance it's going to cover? We can directly use s is equal to ut plus half at squared. As u is going to be 0, we can tell s is going to be half at squared. Half at squared. I'm going to use this equation in the downwards direction. If I use for this downward direction, s is going to be 0. After that, sorry, if I use it for downward direction, I'm going to get the acceleration in the positive sign. As the acceleration is towards the earth, we can directly tell it's going to be towards the earth. It's going to be in the downside. So we can directly use the plus 10. So half into plus 10 is going to be 5. If we use the time interval 1, it's going to be 5. So at the first second, it's going to move for 5. Likewise, in the second second, what would be the movement? So likewise, you need to find all the thing in the what would be the total distance in the second. So if I find the total distance of the second, the total distance for full 2 seconds would be calculated by using that, by substituting the 2 for this t. If I directly substitute this 2 for t, I'll be getting 2 into 10, 20. Total would be 20. Which means at the second is going to move nearly 15 meters. Likewise, you can easily figure it out if you calculate for each and every second. Otherwise, you can get an equation. Let's say this is n second, and after that n minus second, you can get equation for the distance covered in those 2 seconds, total distance, and deduct it and get this one. After that, you can directly substitute 45 for these two, the value you will be getting for this distance, and find the total time taken. So it's also easy, but however, as it's not a big deal for calculating very easily, as this distance is very smaller, 45 meters, you can directly use this method. It would be a little bit easier. So if you use the next part, it's going to be 3 squared 9, 5, 9, 45. The total distance would be 45. So be careful about this one, because they are telling about the 45 meter height is 1 second. This 45 total distance 45 meter is covered in 3 seconds, totally 3 seconds. First 3 seconds they are covered 45. So we can directly tell this is 20, it's going to be 25. So we need to find furthermore. So if we find it for, let's say if I find it for 5 seconds, I'll be getting, if I 25 into 525. So this is going to be 125. If I find it for 4 seconds, if it would be for 16, 8, 18, 10, 8. So like this one, 8. So 45 into 80 is going to give the return of 35. At the 4th second, it's going to move 35 meters. At the 4th second, it's going to be 45. Sorry, at the 5th second, it's going to be 45 meters. Actually, you can see a relationship between here as the free fall happens, which means the initial velocity is 0. The displacement is going to increase each and every second by 10. So you can also note this one. It will be useful for your other questions too. So from these, we can directly tell we have already find that this is going to be 125, as at the 5th second it's going to pass 45 meters. The answer would be this one. The main thing is, as they have given the only probable answer is 125, you can get this one. Sometimes if they give anything above this 125, it might be correct if they haven't mentioned any other clues for you. So they won't give the answers right like that. But the thing over here is, or if they give anything like that one, you can get all 3 answers. Let's say if they give the answer as 128, it will also the correct answer, as when it's passing the 125, it will automatically pass this 45 meter requirement. So if they give the both answer, you need to select both ones. Okay. The 31st, the distance traveled by a particle is given by S. They are given the distance, the initial velocity of the particle is. So initial velocity of the particle is, which means we need to find the differentiation of this one. After that, we need to use the substitution, which is t is equals to 0, because they are asking about the initial velocity. You can use this one. So I'm not going to do this one, as it's not little difficult. I hope you can easily do this one. It's going to, you will be having the answer of A. Second unit, you need to differentiate this. After that, you need to use their values. The particle is thrown in upward direction with velocity v known. It passes through a point P of height h at t1. So they are asking about, they are going to throw a particle upward direction with v known. It passes through a point P of height h. at time t1 and t2, so t1 plus t2 would be. So there's the equation directly, you can use that. But here, yeah, I've asked about that one. Let's see, we are going to throw it by b naught. Here's the particle, so this is h, sorry, this is the distance is h. So here, actually, I already noted that when we are throwing an object at the same location, at the point, the particle will return to the same location again 2 times, or in a position, the particle will stay at 2 instantaneous time. So let's say this is t, I think they are marked as t1 and t2, yes. They are marked as t1 and t2. So the thing over here is, we can directly get an equation for this. Let's say how we are going to get the equation is, we can directly substitute, use x is equal to ut plus half at square, as actually we need, before using the equation, you need to check what are the variables you know and what are the variables you need to find. If you, if there's a one component you need to find, you can directly use this equation. As in this here, in this instance, x is equal to ut plus half h square. Actually, we need to find the time, the relationship between time. Actually, we know what's the value of g, what's the value of s, they are mentioned about h, and what's the initial velocity, we know. So we knew other 3 values, we need to find the relationship between t, one variable, so we can directly use this one. So if I use this one, I'll be getting h is equals to u is equal to v naught t. Let's say I'm going to use minus sign over here because I'm going to consider in this direction minus half g t squared. Half g t squared. So the point over here is, we need to find there, as this is a quadratic equation, there would be 2 answers for t. So the question is, we need to find t1 plus t2. So let's arrange this equation for a format. It's a little bit clumsy. So if I arrange this, I'll be getting g by 2 t squared minus v naught t plus h going to be 0. So the actual point over here is, you can simplify this and find this value of, find the value of t, and for t1 there will be 2 answers. From that you can directly get the answer for t1 and t2. After that you can directly add this one and get the answer. If you solve this, t is equals to minus b plus or minus root of b squared minus 4ac over 2a. You can directly use these and find these 2 answers for t1 and t2 and get the answers. However, there is a short method, so I'm going to do that short method. In a quadratic equation, you can directly use this one. Let's say these 2 answers, the two solution called, let's name as t1 and t2. The t1 plus t2 would be equals to minus b over a. You can directly use this one. Likewise, you can use another equation also. t1 into t2 would be, in a quadruple equation, you can directly use that. t1 over t2 would be c over a. So you can always use this one to find out that. But here, you can't get the individual answer for t1 and t2. However, you can find any addition or multiplication. Most probably in the questions, they will ask about this. They won't ask any individual solution, most probably. So it doesn't mean you won't get it all, but most probably they will ask like these two. So if you're finding the t1 plus t2 is equal to minus b over a in this equation, minus b would be here. B would be this. And this is the a value of this equation, ax squared plus bx plus c. So we can tell the minus BA, so minus, I'm going to write this is a B. So B is minus V naught, so minus is automatically become plus, so we can write this is going to be V naught over, we need to divide it by G by 2, A. So if you simplify this, you will be getting 2 V naught over G. The thing over here is you can directly use T1 plus T2, any two variables in a quadratic equation. You can use any two variables. The solution of two variables would be T1 plus T2 is equal to minus B over A, and the T1 into T2 would be C over A. So careful about the signs. If when you are considering about the T1 plus T2, it's going to be minus B over A. However, in this question, that B is minus B naught, we are going to use this direction. Hope you are clear with this. Oh, sorry. Okay. The particle is thrown in upward direction with initial velocity p naught. Yes, they are asking about the same question, so you can easily figure it out by finding the c over a value t1 into t2. Yes, so I'm going to skip that. You can easily try that and find the answer. Ball A is thrown in upward from the top of a tower. So the carefully read this question. They are going to throw the ball from the top of the tower to upward direction. In the first questions, the previous question, we have answered from, we have found that they have put the ball from the restaurant, which means there's a free fall. However, in this question, they are going to throw upwards from the top of the tower height edge. At the same time, ball B starts to fall from that point. When A comes to the top of the tower, B reaches the ground. Find the time to reach maximum height of A. Okay, let's do that. When you are doing the questions like this, make a sketch so that it would be easy to figure it out what's happening over here. Ball A is thrown in upwards from the top of that. So I'm going to draw like this. This is H. Let's say this is the ball and we are going to throw. I think they haven't mentioned the velocity over here. Time ball B starts to fall from that point. So it's going to fall from, the B is going to fall from that point, which means the initial velocity is 0. So after that, it's going to reach this one. Actually, we don't know the time. So let's say this is the time t. But the thing over here is actually we knew that we will be returning that ball in that A direction at the same time interval, which means it's going to return at the time t, it's going to return to the same height at the time t. So the question over here is we need to find what's the time taken to reach the maximum height of A. So over here, how to find the value of for t. So if you draw a sketchable diagram like this, you can easily figure it out what's going to happen or what we need to use over here. So what can we find using this data? So actually, we don't know what we need to do. If you don't know what you need to do, try to figure it out what you can do over here. In this case, actually, we knew the value of the velocity, initial velocity, and we need to figure it out the time so that only we can use it for here. And we knew that the displacement of this one, h. So from that, we can find this value of t. How to find that is, we can directly use s is equal to ut plus half at squared for that b's motion. If I use it in the downward direction, it's going to be s is equal to h as from this point, from the initial point. The end point is in the downward direction. So when I'm using this s is equal to ut plus half at squared in this downward direction, it's going to be plus. So h is equals to ut, the initial velocity is 0, so there's no problem, we can easily throw it out. Okay, let's throw it out, the ut, and the next part is half g t squared. So from that, we can find this t would be equal to root of 2h over g. So now we have found what's the time taken for A2, for A, what's the time taken for A to reach its maximum height and return to its initial position. So over here, actually we knew that the time taken for reaching the maximum height would be half of the total time for trying A. So from that we can tell it's going to be root of 2h by g divided by 1 over 2. Because it's going to be half of the time of the total time. If you draw a line, try to like this, you can make it easily find it out. So it's going to be 2h over g. If you simplify this, you will be getting the C answer. If you bring the 2 into that root, it's going to be root 4. And you can directly count down these 2 and 4. It's going to be 2g over, sorry, h over 2g. So in the 35 question, in the figure velocity v position graph is given. So here they have mentioned about the velocity position graph. So here they have given the velocity in the y-axis, in the x-axis they are making about the the position. So over here we need to find what's the equation about this one. So over here, first of all, we need to find, there are many methods to find the equation of a graph, so you can easily figure it out. So now, first of all, we need to find what's the gradient of this one. Actually, we can find the gradient of this one. Let's say this is going to be phi is equals to mx plus c. I'm going to write mx plus c. We can easily figure it out. What's the value of c? Is going to be v naught. V naught. C is an intercept. So intercept would be v naught. What's the intercept of this graph, and this where the point in that y-axis is going to be intersecting at this v naught point. Not, that is not minus, so we can directly cut off these two ones. After that, we need to find what's the value of m, the gradient. When we are finding the gradient, we can take this right angle triangle. If you consider this, it's going to be v naught over x naught. So it's going to be v naught over x naught. However, be careful. This is going to be plus sign, because if you have a graph like this in this direction, it should be plus. So we can directly tell it's going to be v naught over x naught. But I think there's a little bit wrong. They should mark it like minus x naught over here, because it's in the negative direction. It's in the x is in the negative direction. You should mark it as, it means minus 4 or minus 3. It's going to be minus x naught. So over here, you can directly substitute over here. If you substitute v naught, or the minus x naught means this minus, you need to use minus v naught over, sorry, this is going to be v naught over minus x naught. So you'll be getting, so I think I am confused. Sorry. We don't need to consider about these things. You need to use this tan theta angle. If you use this tan theta, it's going to be v naught over x naught. Actually, you need this minus sign over here, because if you don't put this minus x naught, which simply means that x naught is going to have a minus direction, or minus value of the x naught will have a minus position, minus value. If that is minus, the answer would be in this minus. The gradient is plus. We can directly tell if it's in this acute angle, that tan theta, this theta is an acute angle, we can directly tell it's going to be plus. So it would be better if here, if they mark it like minus x naught. I hope you can get it. The thing over here, there might be some printing mistake also, but I'm not sure about that. The thing here is, if we don't put it like that, actually we will consider it this as minus value. If we take this as this side as plus, we are going to take this minus. So if you take a value for x naught, it's going to be minus 4. If it's minus 4, if b divided by b naught divided by this minus, so it's going to return the gradient of minus value. It can't be. So it would be, if we take as a minus x naught, the answer would be this one. If it doesn't take that minus, you will be getting this answer. So please check with other papers too. But here they are marked with the D answer, 35 answer. So if they are giving the D answer, you need to take this as a minus x naught. If you have any suggestion, please comment below so I can also learn it from that. Okay, thank you. Thank you in advance. Okay, let's move to 36. In the figure, there's a graph of a to x. So there's a graph in the y-axis. They have marked about the acceleration in the x direction. They are asking about the position x, yes, for a moving particle. Hence, dA over dt is equals to, we need to find what's the graph or what's the value of this one. So they are asking about, there's a graph of a to x. So they're asking about what's the velocity, what's the equation of velocity, what's the, in the simple terms we can tell, we need to find what's the velocity over here. But they have given the acceleration as well as how the acceleration change with x. So let's try to figure it out. So I think there's a little bit mistake we have made. So when we are considering about this a, they haven't mentioned about that this is an acceleration. So we can directly take it as like this is a y direction vector direction displacement. If I take it like that, we are going to find that dA over dt, which means we are going to find the velocity in the vertical direction. If you find that, we need to directly find what's the gradient over this. So when we are finding the gradient, the thing over here is as it's in this side, which means it's as in the previous question we have talked about the acute angle. However, here we are going to talk the angle above 90 degrees, so that we can tell it's going to return the answer of minus. We need to take the minus. In the next part, we are going to take what's the tangent. So if we are considering the tangent about this x-axis, it would be returning a naught over x naught. So it's going to be minus a naught over x naught. This would be the gradient. So the answer would be, for the 36 would be C. So they have also mentioned that, but be careful about this notation because they haven't mentioned about that acceleration over here. That's another displacement variable. Take like that. In the next question, they have clearly mentioned the particle is moving in a straight line with initial velocity of 10 meters per second, a graph of acceleration time. So they have the initial velocity they have given, a graph of acceleration time in the particle, find the velocity at t is equal to 10 seconds. So it's like a previous question we have already did. So in that one, if you have a diagram of, or you have a graph of acceleration time graph, you can directly use this thing, which means you can directly use that area covered by that graph, and the x-axis would give the velocity change. So I'm going to use these two. They're asking about the final velocity at t is equal to 10 seconds, but they have given the initial velocity. Why is that? In the previous question, we didn't want to calculate about these the initial velocity. When we are doing the previous question, we only took the velocity change. We need not only the velocity change. However, in this question, we don't want the velocity change. We need to find what's the final velocity. So if we knew the velocity change, we can directly tell what's meant by the velocity change is final minus initial, final velocity minus initial velocity. Remember this, if they ask about any changes, velocity change either or displacement change or any changes or acceleration change, it simply means you need to figure it out the final value and deduct the initial value. If you do so, you will be getting the velocity or any changes. So changes means in the physics mechanical way, you can directly tell final minus initial. So over here, they are asking about the final minus initial. We already knew that they have given us 10. So initial will be equals to the area, the velocity change. If you find the area for 10 seconds, it will be written half into 5 into 10. So it's going to be 25. So after that, we have the equation right here. Final velocity minus initial velocity is equals to 25. So if we bring the initial velocity to the next side, it's going to be 25 plus 10 is going to be return the value of 35. So the final answer would be 37. Would be, wait a minute, B. I think there's a wrong answer marked over here. So first of all, you need to find the area of this. It will return the answer for this one, for the velocity change. After that, you need to add this initial velocity of 10 meters per second because of this one. You need to know what's meant by the velocity change. Otherwise, it would be a little bit difficult to continue this question. Okay, let's move on. The graph of moving body with constant acceleration is given the figure. So they have marked it as constant acceleration. So please mark that. If they are giving a data, you should use that. Most probably 99% you should use that to derive the answer. You get the correct answer. What's the velocity after time t? So from this graph also you can directly tell the acceleration is constant. That's V is moving, V is having a straight line. So gradient of this graph would be same. So that gradient would be equals to acceleration. So you can tell the acceleration is equals to a constant value. So over here they're asking about the velocity after time t. So for that, how to find that? So first of all, you need to find an equation for this line. Otherwise, it would be a little difficult for you to continue. As you can see over here, they have also find, and it's similar to an equation, y is equals to mx plus c. So for that one here, actually we knew that what's the value of y over here? It's going to be OA plus AD. So OA plus AD is the value for y at the time t. They're asking about the velocity after time t. So we can calculate y is equals to mx c. If we substitute on the y is equal to mx plus c, the y is going to be OA plus AD, but they are not asking about that. The next part is mx plus c. What's the intersection? So if you consider the intercept, what's the line, the point where that line and the y-axis are intersecting would be A. So what's the value of this is, we can directly put that like A. Here they are mentioned like OA. That's the length of the intercept of the point, the y-axis point, y-axis coordinate. So we should write y is equal to mx plus c. The c would be OA. So we can directly tell the answer would be this or this or this. So the next part would be y is equal to mx plus c. We have figured it out c. So the next part we need to figure it out what's the value of m. So when we are considering about the m, you can take any triangle, but here they are already given a right angle triangle over here. So if you are finding the tan theta tangent for this, it's going to be DC over BC. So if you consider this DC over BC, DC over BC, all three are getting the same gradient. So all three can be correct. The next time is you need to figure it out the value for x. So when you are finding the value of x, you can directly figure it out from this graph. For this question, they're asking about the time interval t. So t, at the t, you can tell the length would be this one. So they are marked it as OE. So you can directly tell the answer would be this, the first A. For 38, it's going to be A. So in this question, you need to figure it out what's happening over here. And after that, you need to find the equation for this straight line. After that, you can correctly substitute and get the answer. The 39th question, the graph given in the figure shows the body is moving with, as this is a velocity time graph, we can use the gradient will give the acceleration. So if you consider this graph, you can directly tell How to find this gradient? Let's say this is a gradient at this point. I'm going to draw a gradient in that point also. If let's say I'm going to consider this gradient like this side, it's like this. Okay, now I have drawn 3 gradients over 3 points. From that, we can directly tell the gradient. When you are considering the below acceleration of the grade of graph, you can directly tell it depends on the gradient, but it would be a little bit difficult if you consider the negative sign, because in these 3 they are in the 90 more than 90 degrees angle. It's going to be minus gradient, which means the negative acceleration. So however, how to find this one? So the answer is, you should take whether the velocity is increasing or decreasing. So we need to find that. If you consider this minus sign, you might be confused. Minus sign simply means it's having the velocity in this opposite direction. Doesn't mean it's going to decrease, or I'm talking about the acceleration. When I'm considering the acceleration, it doesn't mean it's going to be deceleration. If there's all things are in the negative sign, as if you find the gradient for these all things or to 3 points, the gradient is in the minus sign, which simply means it doesn't mean all the things are in the deceleration. So you can directly find it would be a little bit difficult to think using that minus sign. So I'm going to use the slope. If you see the slope from the beginning of that graph, you can directly tell initially the slope is very high. After that, it's going to get lower. After that, it's lower. So from this, we can directly tell, let's consider this slope as an acceleration. So in this position, the acceleration is highest. After that, this acceleration is getting low a little bit. After that, it's going to get much low slope, which means the acceleration is decreasing. But the thing over here is, we can directly tell as the acceleration is in the negative side, which means it's happening in the negative side. So in the negative side, it's happening, but the thing over here is, it's going to accelerate. It's going to increase its velocity, but the time, the increasing of the velocity, the rate of increasing of the velocity is going to decrease. Let's say in the opposite direction, in the first time, let's say in the time 1, the velocity is, let's take that's 50. It's in the 50. So it's in the 50. So if you consider about this one, at the another 1 second, it's going to be 40. So after some time, let's say this is t time interval 1. At that same time interval 1, it's going to be, let's say this is going to be 35, which simply means it's not going to, oh, sorry, I have made a mistake over here. Here, the velocity is going to decrease over with the time. We can directly tell it's going to be deceleration. The point over here is, in this paper, they are given the answer of decreasing acceleration. The thing over here is decreasing acceleration as well as the deceleration are not same. Please note this one. Might be in this concept, it might be same in the question. They are considering same because they are about telling the increasing velocity, that's wrong. Constant velocity, that's wrong. Increasing acceleration, that's also wrong. But the thing over here is, if you take the acceleration in this side, in the negative side, it's going to be decreasing acceleration. But over here, if you take in this positive side, what's going to happen over here is, it's going to decelerate. It's going to decelerate. As the velocity is going to decrease, it's going to decelerate directly. So also when it's decelerating, we can tell it's going to be, the decelerating rate of decelerating in the first second is going to decelerate or reduce the velocity by 10. After the next second, it's going to reduce by only 5, which means the rate of decelerating is decreasing. So we can tell it's going to be decreasing deceleration in this side. Decreasing deceleration, not acceleration. Note that. In other terms, we can directly tell if we consider in the left direction, but when we are considering in the right, normally we will consider in the right direction. If they have asked a question like this, you need to consider in the right direction. So there is no answer. I think there's a little bit mistake. So there will be a deceleration. The deceleration is going to slower, or deceleration is going to reduce with time. As in the first second, it's going to reduce by 10. After the next second, from the next second, it's going to reduce to only 5 meters per second. The velocity is going to reduce only 5. So deceleration is decreasing. In other terms, if you take in the negative side or in the left side, you can tell it's an increasing acceleration. If you change that side, acceleration, you can tell it in the opposite side. So the point over here is that I think we need to normally consider in the right angle direction. If they haven't mentioned anything, as they have also mentioned that velocity in the upwards like this, we normally take in the right hand direction. If you take so, we will be getting decreasing deceleration. So in the other terms, we can tell it like if you change the direction, and you can tell it like increasing acceleration like that also. But the main point over here is you can't, normally we will tell in the same direction. So it would be decreasing deceleration, not an acceleration. So it's the, as the velocity is going to decrease. Hope you are clear with this. If you have any doubts, please comment below. And if you have any suggestions, please comment below, because this is also new to me too. So let's try to solve together. Okay. Slope of the velocity time graph gives dash of a moving body. So 40. So when we are considering about this one, okay. The slope of the velocity time graph gives, so this is a question we have done in this previous question also. You can directly check it's going to give the acceleration. The intercept of the velocity time graph of the velocity axis gives. So the intercept of velocity time graph on the velocity axis will give the velocity. Surely it will give the velocity, and it will give at the time 0, which means it will return the initial velocity. Okay. So here are the graphs of velocity time of two cars A and B. Find the ratio of the acceleration after time t. So here they are asking about find the ratio of the acceleration after time t. Yes. So here we need to find what's the equation of these two graphs. So here you can directly tell the intercept would be 0 for both. So you can directly find the equation by finding the tangent of these two. If I consider for A, it would be, I think this would be 30. So if I consider this, it's going to be tan 30x. Tan 30x. If I consider this tan 30x, it's going to be 1 by root 3x. So I can write it as x by root 3. For this is for A. Likewise, if you write the equation for B, it's going to be tan 60x. Tan 60 is root 3. So I'm going to write it directly root 3x. The incident intercept is 0. I have already mentioned that. So over here, they are asking about the ratio at the time t, but we can find the ratio of that acceleration. So what means by that acceleration is, actually we already discussed about that. The gradient of this line, velocity time graph, will give the acceleration. So we can recognize the acceleration would be 1 by root 3, the gradient of this graph. Likewise, here we can recognize it's going to return the value of root 3. It's the gradient of this B graph. We can directly use this one. Remember this, In a velocity time diagram, the gradient is known as acceleration. So if we divide 1 by 1, 1 by root 3 divided by root 3, it will be giving 1 by 3. What's the answer? B. So 43rd. Here's the velocity time graph of a motorbike moving in one direction. Calculate the distance covered by it in last 2 seconds. This is a velocity time graph of a motorbike moving in one direction. So they have already mentioned it's going to move in one direction. Calculate the distance covered by it in last 2 seconds. Last 2 seconds means we need to find it 4, 3, 2, 5. 3 to 5. So over here, I think there are they have given the answer total velocity time graph. So I'm not clear whether what's 10 meter, whether it's 10 meter per second or 5. So here I'm going to tell the idea so that sometimes there might be a printing mistake if you are doing a very big paper. So that's not a big deal over here. So the thing over here is when we are calculating the distance covered by last 2 seconds, we need to find this area. So this will give this, they will give the answer. So we need to find what's the area of this. So in the previous question, also, we are discussing about this. When you are given the velocity time graph, you can get the displacement or distance here at it's moving on the same direction. We can use distance over displacement. If you are considering about the distance, we can find the distance by finding the total area relative to that time interval. In that time interval, we can find the interval. We can find that area covered by that graph and that axis. So from that you can find that. However, it seemed to be a little bit wrong over here, 10 meter 5. So I'm not going to further dig into that. So don't forget about that. The idea is you need to find that area within last 2 seconds. So in the next question, they're asking about in the above figure acceleration and time graph is given. Hence, what we can tell about this? The acceleration is going to from this we can probably tell the acceleration is going to increase, or with the time it's going to increase. So over here we need to find hence what's the relationship between V and A, whether V is proportion to A or what's going to happen over here. So you need to find what's okay. So over here, just imagine what's happening over here. At this time, the acceleration is in the negative side, which means it's going to decelerate. So let's say I'm going to draw a graph like this so that we can figure it out what's happening over here. So if I draw a diagram, we'll be getting at this time, it's going to, at the first time, if I draw a diagram for VT graph, at the initial position, it's having decelerating, and the decelerating is going to slow down and it's going to be 0 at some certain value. So let's say it's going to be like, and it's going to get the 0 value. After that, it's going to accelerate. So it's like a curve, hyperbola. So if you have a diagram like this, if you have a like this, you can directly tell it's going to be squared or anything, but you need to find whether it's a squared or a cube. So that's another main thing you need to figure it out. So how we are going to figure it out? So that you can directly tell, actually we knew that A is a proportion. However, it's not true fully, which means it's going to be, the graph is, as you can see over here, it's increasing graph. However, and it's a proportionately it's increasing. However, there's a intercept. If the intercept is 0, we can recognize it's a proportional. However, it's not fully, we can't tell it directly, but if you consider like this, is when the chi is increasing, A is going to increase at the same proportion, like that. But they are a little bit different, rather than there's no scale over here, we can recognize A is merely a proportion to T, like that. So over here, you can consider like this, how we are going to get this V from B, the area A, the acceleration of A, we have derived by using dV by dt. So from this one, we can tell when from this we can directly tell the dA by dt would be constant. dA by dt would be a constant. Likewise, when we are considering about the V, they have given, let's say this is proportionate to A squared. Actually, we don't know what's the square of whether it's A cube or nothing. But let's assume whether it's a thing, or let's say this is A to the power n. Actually, we don't know what is that. Let's say this is A to the power n over dt. If we differentiate over A to the power n over t, actually we knew that it's going to be A n minus 1. Before that, I need to put n minus 1. So n minus 1 into A to the power n minus 1 into dA by dt. So this is the equation we will be derived, which is equals to A. Why I'm doing this is, from this we can directly tell, over here you can see this n minus 1 is a constant. As if we determine the value for n, we can directly tell n minus 1 is a constant. Likewise, we can directly tell dA by dt is also a constant, because we can directly derive that as the dA area, the acceleration with versus time is going to be constant. The ratio, the rate of change is constant. We can directly tell it's a constant. From that, we can directly tell dA by dt is also a constant. So these are two constant. Let's say they are cancelling off anything, no problem. But however, when we are considering about this A, it should be equal to A to the power n minus 1. So for it to be equal, we can directly tell this n minus 1 should be equals to 1, which simply means n should be equals to 2. So thing over here is it's not true, or it's not a true statement, A proportion to T, but the meaning I have written like this is when the A is increasing, the T is easily increasing at the same rate of change is same. So we can directly tell that dA by dt is equals to constant. From this one, likewise, we can directly tell A is equals to dV by dt. And for the instance of V, we can directly write A to the power n. We actually don't know a relationship between V and A, however, so that we can correctly write like A to the power n. You can even write a constant K into A to the power n. We are neglecting the values of constants over here. So after that, we can cut down the dA by dt and the n minus 1 as they are constant. After that, we can directly equate them, the powers, and we can derive the answer. It's a little bit trickier part. However, the main thing over here is you need to use some derivative knowledge on this. Okay, let's move forward. The graph of displacement, I think displacement, it would be displacement time for an object is given in the figure in which part of the graph the acceleration of the particle is positive. So they are given the check displacement versus time, and they are asking about the which part the acceleration of this particle is positive. So which simply means we need to figure it out what's happening over here. In this other way, you can directly draw a velocity diagram graph and figure it out. It would be a little bit easier if you, because you don't need to think too much if you draw a velocity diagram. So I'm going to try in that method. So in this case, when I'm directly drawing the velocity diagram, I can draw it by using the gradient method. So when I'm considering the gradient, if in this position, we can calculate it's going to be in this direction. At the A, the velocity is going to be 0. At B, it's going to be in the negative sign. However, actually, we don't know whether it's changing linearly. However, I'm going to take like this one. If I take this one, there's a velocity over here in this direction. After that, it's going to be 0. The velocity is decreasing at the positive and it's going to be 0. After that, it's in the negative side as the gradient is in the negative. So we can calculate it's going to be in this side. Let's say in this side. Sometimes it might be in the it's like a curved line. Actually, we can't tell without the equations and all the stuffs, but generally it's going to decrease and it's first in the plus sign, and then the next part, latter part is in the next line. The thing over here is when we are considering about this one, how to find this acceleration. What's the acceleration part of the positive? As you can see over here, the gradient of this velocity diagram is going to be negative all the way. All sign is going to be negative. From that, you can directly tell it's going to get the answer of D. Why is that? The reason behind this was it's all the thing is in the deceleration part, which means the acceleration is in the negative sign. So that's a problem over here. Likewise, I think in the previous question we have started a little bit. Yes, in this question, you can take that decreasing the deceleration. Otherwise, which means the acceleration in negative sign, they can also consider as acceleration in negative sign also according to that question. So you can tell this would be the answer because the acceleration in this negative sign, which means the deceleration, can be. So it doesn't mean always there's a plus sign over here. So we can directly consider this is a minus acceleration. After that, we can tell this is decreasing, while we have already found this is a decreasing deceleration, so or retardation. However, here you can take it like acceleration in the negative sign, as in the next question we have answered like this. So it's a not positive at any part, so like this. So in the 46th question, in a uniformly accelerated motion, the slope of velocity time graph gives in a uniformly accelerated motion set, which means the acceleration is in the uniformly acceleration, which means a constant value. So when we are considering about the slope of the velocity time graph, what will be returned? Actually, we knew that the velocity time graph slope will always return the acceleration. There's no changes. Velocity time graph gradient will always return the acceleration. The area covered by the curve of BT graph and the time axis equals to magnitude of, so we have already discussed about this, displacement, with the answer would be C. Or otherwise we can tell like change in displacement, so total displacement, so anything is fine. Okay. In the 48th question, an object moves in a straight line. You start from a rest and its acceleration is 2 meters second squared minus square. After reaching a certain point, it comes back to the original position. So over here, it starting from the rest, and its acceleration is 2 meters second minus 2. After reaching a certain point, it comes back to the original point. In this movement, its acceleration is minus 3 meters second minus 2. Till it comes to rest, the total time taken to the movement is 5 seconds. Calculate the maximum velocity. So over here, we need to find the maximum velocity. If you have a question like this, you can either use the equation method over here, but Here I'm going to tell you something different. I'm going to use a graph method. If you plot a graph, you can easily figure it out what's going to happen over here. So let's say this is the acceleration time graph. As they are given the acceleration time graph, you can directly draw the acceleration graph. Either you can draw the velocity diagram directly, velocity graph directly. But for this instance, I'm going to, as this is the first method when we are discussing this question, so I'm going to draw this one first. When we consider this, the acceleration will be 2, 4 sometime after reaching certain point. After that, in this moment, its acceleration till it comes to rest. So certain point, it comes back to moves in a straight line, starts from the rest and its acceleration. After reaching a certain point, it comes back to the original point. So I'm a little bit confused about it. An object moves in a straight line. It starts from the rest and its acceleration is 2 meters per second minus 2, which means it's going to accelerate over here, which means the velocity is going to increase and increase. After reaching a certain point, it comes back to the original point. So it's going to come back to the original point. In this moment, when it's going to return, in this moment, its acceleration is minus 3 meters per second minus 2. So let's say this is minus 3 second minus 2 over here. So don't consider about this. It's going to be minus 3 meters per second minus 2 till it comes to rest. The total time taken for a movement is 5 seconds. Calculate the maximum velocity. So they are given this has totally taken 5. So there are many critical ideas, critical points over hidden data inside this one. So the main point is after reaching a certain point, it comes back to the original point. So within the 5 seconds, it has came to return to say the same position with the velocity of 0 because it comes to a rest. And they have mentioned actually what's happening over here is the car is going to return. So the object is going to start from a point, from a rest, which means velocity is 0. So if I draw a velocity diagram over here, it's going to start from a rest. After that, it's going to accelerate. Actually, we don't know how long it has been accelerating. So let's say this is 2 meters per second minus 2. The gradient is 2 meters per second minus. After that, in a certain time period, it's going to have a deceleration of minus 3. So it's like this, minus 3. So after that, it's going to get a velocity of 0 at the rest, at the initial point. Actually, we knew that this one the velocity is going to be in the negative sign too. So the problem over here is it after reaching a certain point, it comes back to the original point. That's true. However, in this moment, its acceleration is minus 3 meters. It's going to go for a certain point. After that, it's going to decelerate. The thing is, which decelerating means however, it's going in the same direction, velocity. It's not becoming 0 until a certain time, till it comes to rest. So when it's coming to the rest, it will already move from a distance from that original point. Up to this point only, they have given this have taken 5 meters per second. So that's the question. Try to understand the question well. It didn't came for the original point at the moment after 5 seconds. First of all, it's going to start from the rest and it's going to acceleration 2 meters per second minus 2. After reaching a certain point, it's trying to coming back to that original point. In this moment, when it's trying, it's after that certain point, it's going to decelerate. However, when it's decelerate, which means the velocity is not 0, which means the velocity is not going to return in the negative sign, in the back to original position. However, it's going to go in the positive direction, but the velocity is going to decrease because of the deceleration, minus 3 ms minus 2 acceleration. which means the force is acting on the negative side in the direction towards the original point. So when we are considering, the velocity is going to decrease, and it's at a one instant is going to be 0. For the total time for that movement only, they have given 5 seconds, which means they haven't mentioned about the original point, which means it's trying. However, in that 5 seconds, it's not returning to that original point. So here we need to find what's the maximum velocity over here. The total time, we knew that this is going to be 5. Actually, we knew this is 2 and this is 3. So over here, let's take this is x. If we take like this x, actually we don't know what's this thing. So we need to take a variable name. Actually, in the previous questions also we have mentioned, if you don't know anything or a variable, you can directly use that. In the final answer, it will automatically cut down. So it's x. If I take it like x, either you can take this one time or you can take this one as b. Actually, we did this one, so we can take this as b. All are suitable. So if I take this is b, we can directly tell it's going to be b by 2, twice that. Why is that? Actually, the 2 means it's a gradient of this triangle. That's 2 is a gradient of this triangle. Actually, we knew this value v, so this would be this 2 would be equals to v over this time. So from this we can directly tell this time would be v by 2. Likewise, this 3, I'm going to consider only plus 3 if I consider in this angle. So if I consider this plus 3, is going to equal to this v by this time interval t2. Let's say this is t2. So v by t2 is equals to 3, then t2 will be equals to v by 3. So if I add these two, I'll be getting 5. So we need to simplify this. If we simplify this, 5v is equals to 630, so v is equals to 6, I think. So the 48th answer would be A, that's correct. So the thing over here is, it would be difficult if you don't draw a graph, I think so. So try to plot a graph. If you plot a graph and mark all the things in that graph, it would be very much easy for you guys. I hope it would be a nice method, interesting. Okay, let's move to the next one. The relation between time and displacement of moving particle is given by t is equals to 2 alpha x squared, where alpha is a constant. The shape of x, y. So over here you can tell as it's having a value of t is equal to 2 alpha x squared, which we can directly tell it's going to be hyperbola. The t is in the x-axis and the y-axis in the displacement. It's going to be in the y-axis, I think. It's x to y, it's going to be hyperbola. So if you draw a diagram, you can directly figure it out. So likewise, in the previous question also, we have the graph equation. Let me check. Yes. So the point over here is, here we are not taking about y and x. Here we are taking as x and y, which means in the previous question, I think I can show from the previous question. Here, in this graph, we are given velocity time graph. In the y-axis, there is a velocity. In the x-axis, there is a time. Normally, we will check like this. In the x-axis, we will check the independent variable, which cannot be controlled easily. But in the y-axis, we choose the variable which is changed according to that independent variable. That's known as dependent variable. So over here, we denote it like y, that arrow, and x. However, if you draw like this, you'll be getting another graph like this one. As actually we knew that the x would be the displacement and t is time. So normally we assume that t is equal to when we draw normally t in this x-axis and x in this axis, displacement in this x. So if we draw like this, we will getting an equation x is equals to root of t over 12. So that's a root graph. However, in this case, we are going to consider we are going to consider the next item. We are going to change from this one. We are going to consider the t as y, as they are given x to y. So we are going to consider it as y, and the x squared it as the same x. So if I have an equation like y is equals to mx squared, we can tell directly it's going to be like this one. So that you can tell it's going to be hyperbola. So this is going to give the answer of B. Careful about this notation. This means in the first thing, you need to use this y, and the next, normally we will use the x axis variable. However, in this question, they have changed that. The 15th question, here are the graphs of xt of a moving body. Which of them is not suitable? So over here, you can directly figure it out. The x can be going in any direction. However, which simply means x means that we are going to take x as a displacement. So which means at the same time, if we plot some points over here, which means at the same time there are several displacements. Can it happen? No, sure, not for sure. So we can really tell that it's not true. So this is going to be in a certain period, a particle can't be in many places. That's the thing. So we have figured the second milestone over here. Okay, let's continue. Here are the graphs BT of moving. Which of this is suitable? So I'm not going to repeat this question because I have already discussed about this question. The answer is going to be D, because at the same time, it can't have two velocities. In an imaginary world, it can happen at the time of physics, at the classic mechanics. We haven't studied about this. Okay. In the figure, there is a graph of velocity time for a particle. In the figure, there is a graph of velocity time for a particle. So they have given the graph. Which area shows the displacement covered by the particle after time t? So we need to find the displacement. So what's the equation of, what's the area shows the displacement covered by the particle after time t? So as I have already mentioned, when they asked about the total displacement covered in that time, we need to find the area which covers by that graph with time axis. So when we are considering this, as you can see over here, the area, the graph is denoted by AB. I think AC is a random movement or a random line. So the AB is the line, I think. They are shown covered by the particle. Yes, they have only mentioned that only. So we can recognize the AB is the particle. Really, the main thing is when you are drawing a graph of a particle's velocity, you need to mention that this AC is not a line. So you can plot it like this one. The real graph part is this one. Others are not a graph. We are going to draw some lines to figure it out the value. So we can't draw in a full line, which means we can't draw like a line. We need to show as dotted lines. That would be much easier for students. Okay. So over here, you can directly tell if I consider this, the area would be ABDO. So whether there is the answer, They are mentioned AODCB, I think. AODCBA, yes, close figure. AODCBA, the area, the whole area under this graph. So they have marked all the position. That's a little bit good. AODCBA. Yes. So after that, which part shows the initial velocity of the particle? So when we are considering the initial velocity, the intercept will show the initial velocity at the time. Initial velocity means at the time zero, what's the velocity of that particle? So when I'm considering this, you can directly tell it's going to be A. So the length of this would be OA, so you can directly use that. How will we calculate the acceleration of the particle? As we have already learned, they have mentioned all the things, taking the length of AB. Careful, not the length of AB, we need to find the slope. So they have given like taking slope of AB at the answer D, so you can directly figure it out. So in the 55th question, given graph shows the relations between position and time, which means they are given the graph between the displacement and time. So they are asking about to find the correct graph of acceleration. Be careful, it's not velocity. They are not asking about the velocity, they are asking about the acceleration. However, when you are considering whether they ask acceleration or velocity, you need to draw a velocity diagram graph, velocity graph from and displacement graph. It would be easier to figure it out what's going to be the acceleration or any else. So, however, I'm going to use this technique over here. So let's draw that. First of all, I'm going to draw the velocity diagram graph. From that, I can figure it out the acceleration graph easily. Okay, let's try that. So at the beginning of the point, you can easily figure it out. The gradient of this graph is 0, so the velocity is going to be 0. Okay. At the second point, it's going to decrease, which means it's going to have the negative sign. So at the 2 seconds, it's 3 seconds. Let's take the exact little bit above. Okay. Eraser. Okay. Yes. So I'm going to tell you this. It says 0 and this is 2, marked as 2. This is 4, 6, 8. Okay. Fine. Yes. So at the time being, you can directly tell at the time 0, the velocity is 0 and it's going to decrease, which means it's in the negative sign. You can directly figure it out. It's in the direct negative sign. So negative sign is going to increase. The velocity is increasing in the negative side. So up to the 3rd second, I think. So you can directly tell. I'm going to figure it out by dotted line. So it's going to decrease, but actually we don't know whether it's the curved line or direct line. But at the instance, I'm going to take like direct line. It's like a cos graph. So it's like a cosine graph. We can tell like a curved line, but okay. After this, from the 3rd one, you can directly find, if you see the slope of the gradient, it's going to decrease and getting 0 again at this 4th second, I think. Yes. I think there is not a graph. Okay, let's see that. So at the 4th second, it's going to be 0. Okay, I have finished that. After that, it's going to move ahead from that. From the 6th axis, it's going to, the thing over here is, it's going to get 0 in this 4th. After that, it's going to increase in the plus direction up to 6. Up to 6, it's going to increase. The velocity is going to increase. After that, it's going to decrease up to 8, I think, up to 8. So let's say this is the point 8. So up to 8, it's going to decrease. I think it should be in the second one. Actually speaking, it should be in the second point, I think. There's a little bit mistake in that. Printing, it's not a problem. So if you look like this one. This is not the acceleration time graph. This is the velocity time graph. So they all have mentioned that's the 2 point, as you can directly see it's going to be in this part. So I'm going to go another time. There's a little bit mistake, but not a big deal. At the 2, 4, 6, 8. From this, you can tell it's going to be 0, and this is like. Okay, I have figured it out. Okay, this is the velocity time graph. From this, the question is we need to find what's the acceleration of this one. So when we are considering the acceleration, we need to find the gradient of this. So when we are finding the gradient, actually you can see that this is negative. At this instant, it's going to be plus. Sorry, 0. After that, it's going to be plus for this time. So it's again like this one, I think. Sorry, in this point, it's going to be plus. However, in this case, it's going to be negative. As you can see over here, if you draw a line gradient, it's going to be see the negative. So you can tell it's going to be negative, starting with negative. So the answer would be D, I think. Yes, that's the answer, D, because it's starting from the negative. After that, you can tell at the second, you can directly tell the acceleration going to be 0. So if you see the answer, at the second, it's going to be 0. After that, if you continue for the fourth second, it's going to, again, from the 2 to 4, it's going to, acceleration is going to be in the positive side. If you draw a gradient, it's showing a positive, and it's going to increase up to 2 to 4. So if you see that, it's going to, again, increase. It's like a, you can either use this one, or you can directly find an equation for this, as there's a little mistake over here. If you consider as a cosine graph, let's see, this is a cosine graph, this is 2 point. You can take y is equals to cos time, cos t. If you differentiate, you will get velocity as minus sine t. If you differentiate this one, again, acceleration would be minus cos. So minus cos t, like that. So it's going to be written the cos graph again, but in the minus direction. So it's in the opposite direction to displacement. So in the 56th, here are the displacement time graph of B and V. If V and VB are velocities of the particle respectively, then BA over BB. So we have already done a question like this. I think this question has been repeated again. We need to find the velocity. Yes, they are asking about, now they are asking about the VA. Sorry. In the previous question, we done the same, but we found the acceleration of it. So here they are asking about the ratio of BA over B. At the same time, I think they need to mention, they need to mention over here this. This is a displacement time graph. So you can directly figure it out, BA and BT. For BA, you can use, from the displacement time graph, you can figure it out the velocity of that particle by finding the gradient. If you find the gradient of this graph, going to be tan 30, and this one tan 60. So the velocity of B would be tan 60, and velocity of A would be tan 30. After that, you can directly divide it by 30. So again, they are given as time graph from a position to graph of velocity time. They are asking about the velocity time graph, as this is a, so here let's use the equation method. It's like a sine t graph. So if I take it like y proportion to sine t, or y is equals to sine t, no the big problem. So if you take y is equals to sine t graph, they're asking about, so the velocity you need to differentiate. If you differentiate sine, you will be getting cos. So answer would be A. For the 57, the answer would be A. Yes, that's the answer. So 58, particle A and B are released from the same height at an interval of 2 seconds. After some time t, the distance between A and B is 100. Calculate the time t. So for this question, you need to use the calculations, otherwise it will be a little difficult if you use the graph method. So let's say the A and B are released from the same height. So actually we don't know what the height is. Of course, I think we don't need that too. So same height at the t is equals to 0. If you have a question like this, please draw a diagram like this. So it will be easy to figure it out what's happening over here. T is equals to 2. So at the t is equals to 2, we are going to drop another ball, A, let's say B, yes. After some time t means if this ball, this A ball have been traveled for some distance. Let's say this is D. Actually, we don't know, so let's say this is D. No, don't scare to introduce any variable, any unknown variable, guys. If you can produce or you can make any unknown variables, and the answer would be automatically cut down when you finally get the answer. So here, if you figure it out, this is, let's make this t. After some time t, the distance. So these have traveled up to time t. So t is equal to t. When I'm considering the second ball, B, it can be only traveled for t minus 2 seconds. Why is that? They have already mentioned we are dropping that ball after the 2 seconds only. So if I'm considering about the total time t interval, we can directly tell we need to deduct that 2 seconds from that total time for the B's motion. So now we have found that it's going to be d, and this distance would be, from the question we can tell A and B is 100, so this would be d minus 100. So now we have plot all the data they have given, but there are some details which are hidden because particle, they are going to drop that, which means the velocity is 0, initial velocity is 0. So over here, how to calculate the time t? So for here, we can use for the A object, a particle, we can directly use s is equal to ut plus half a squared, but the initial velocity is 0. We can directly use s is equal to half a squared. The S means the displacement would be d is equals to half. The acceleration would be g, and the time is t squared. Likewise, we can use the same equation for the particle B. If I use that, the distance would be d minus 100 is equals to u is 0. So we can directly write half into g into t minus 2 squared. Be aware of that t minus 2 squared as b only traveled for only t minus 2 seconds. So if now we have got two equations, we can directly substitute 10 for g, and there are two unknown variables. Here we need to find the answer for t, so we can directly substitute d is equal to half gt squared over here and solve that. You will be getting the answer. They have given that answer would be 6 seconds, I think. Yes, they have given us 6 seconds. Try it in your own. Okay, let's move to the question. Next question. As shown in the figure A, a particle is released from P. It reached at point Q at time t1. So we ask that graph. Shown the figure. I think they have missed that figure. Yes. Well, let's check whether we can do without the figure. Shown in the figure, particles released from P, it reached at point Q at time t1, reached that point. Oh yes, we can't do that. Okay, let's move to the next one. A particle moves in a straight line. Its position is given by x is equal to find the ratio of initial velocity and initial acceleration. So over here, we need to find what's the equation between them. For that, we actually knew that when we differentiate the displacement, we are going to get the velocity equation for velocity. Likewise, if we differentiate another time, we will be getting the equation for acceleration. So from that, after getting those equations, we need to substitute 0 for that time interval, which means we need to substitute t for that 0 because we are going to find the initial velocity and the initial acceleration. After that, you can divide it by those things and you will get the ratio. If I do so, I'll be getting 5 minus 60 If we differentiate another time, it will be getting -6. So if you substitute t0 for t, it will be getting 5 over -6. Yes, next part. The particle is moving in a circle of radius r with a constant speed. It covers an angle theta in some time interval. Find displacement in the interval of time. The particle is moving in a circle of radius r with constant speed. It covers an angle theta in some time interval. So they have mentioned there's a circle. Let's draw a circle. Some ugly circle, yes. So okay. So let's make this is r, and actually we don't know how, whether it's theta is, what's the value of theta. Let's make it like this, theta within a certain time interval. Find displacement in this time interval of time. Sorry, displacement. So actually we knew that the displacement would be the shortest distance between these 2 points. So we can directly tell it's going to be this straight line. So how we are going to find this one? So that's the question. So if you figure it out, we can directly tell these lengths are equal. So it's like a double side equal triangle. So if you draw a line from this one, perpendicular line, it will cut down these two. Likewise, it will cut down this angle into 2. This is theta by 2, and this would be theta by 2. It will cut the angle in the same. This is theta by 2, and this would be theta by 2. From that, we can directly tell us if you take this triangle, it's a basic geometry. So if you take this r, and this would be theta by 2, and you can directly figure it out. This would be r cos theta by 2. Sorry, r sin theta by 2. If you consider this triangle, it's going to be r sin theta by 2. Likewise, you can figure it out. This 2, it's going to be r sin theta 2. Sometimes you might have a doubt whether when the theta is an angle which is above 90, is it equal? Yes, it would be equal. So, however, it would be difficult if you're going to find that, so that I have taken that theta as this one, the acute angle. However, you can also try to that too, but they are given for all theta, so you can directly figure it out for one and finalize the answer and get the final answer. The particle is moving in a straight line with initial velocity of 200 meters per second minus 1. Acceleration of the particle is given by 8 square. Find velocity of the particle at 10 seconds. So here they have given the initial velocity. So why they are given that? Before they are also in the previous questions, they are given the x, the time x relationship, displacement time relationship. After that, we have differentiated them and figured out the value of the velocity. However, in this question, they are giving the acceleration. How are we going to find the velocity equation from this? Is actually we knew that we need to integrate this. If I integrate the acceleration, we are going to get the velocity. If I integrate the 3t squared, it will be 3t cube over 3. So it will return the value of t cube minus, if I differentiate t, it's going to be t squared by 2. It's going to return the t squared. Remember, there is a constant value. You need to put a parameter. C, constant value. So how to find this C? Because when we can't directly substitute 10 over here for time and get the answer, because we don't know what's the value of C. Therefore, they are given the 200 meters per second, the initial velocity of 200 meters per second. So we can directly tell how to use this one is, the initial velocity means at the time 0, we can directly tell the velocity is 200. So if I substitute time 0 for here, you will be getting B is equals to C. However, we knew that B is equals to 200, so that you can directly tell C is 200. So the constant value would be 200. So now we have found this one. So after that, we can directly tell, we can directly substitute 10 for this t. We'll be getting 1000 minus 100 plus 200. We'll be getting 1100. So if they have given any data, please try to use them. You will be getting the answer very quickly. Okay, let's move to next. Sorry. Okay. Angle of projection, maximum height, and time to reach maximum height of particle, h and tm. Basically, find the true relation. Oh, it's a little bit difficult. Angle of projection they have given, maximum height and time to reach maximum height. Okay, the theta is the angle of projection. What's the angle of projection they have made? And h is the maximum height. So let's draw like this. So what's mean by this maximum height? You have a hidden data in that, which means the velocity, the vertical velocity would be 0. So I'm going to mark like this, please. And Tm, the time taken is Tm. So h, and actually we don't know what's the velocity over here. So let's mark it as v. And this one, let's say this is theta, they are given theta. Okay. So the question is, we need to find the relationship within these three. So over here, actually we knew that this is h, the maximum height, h, and the time taken for that, Tm. So how we are going to find it? Well, first of all, we need to find what's the equation we can use over here. Whether we can use v squared is equal to u squared plus 2as, that's doubtful because we need to use the time in that equation. However, if you use v squared plus u is equal to u squared plus 2as, there is no time. So we can't use that. The next item is v is equal to u plus 80. Okay, whether we can use it. V is equal to u plus 80. Actually, we can't use this one also. Why is that? There is v, no problem. The final velocity is 0, so we need to use that. So it's okay. But there is no point of using that h, as there is no s. So the next part is s is equal to ut plus half it square. So there is s, yes. Time is yes, okay. The u part, the initial velocity. So there is no initial velocity. The problem is you can use any equation first of all. After that, if you find that it's not enough, you need to use another equation and merge those two equations and get the answer. If you figure it out what the equation you need to use at the first time correctly, you will get the answer at the first time. So that's the main point. So over here, I have figured it out. S is equal to ut plus half it squared would be a little bit easier for me because there is s and there's a variable for t. And the problem is actually we only knew the final velocity 0. So how to use the initial velocity? Actually, we don't know what's the velocity. So sorry for that. So can we change a little bit can we little bit change that thing? Let's think about the half, another half, what is going to be happening in that half. It's going to be the same. If I consider this motion, what's going to happen? The initial velocity in the vertical direction would be 0, and the time interval would be the same, Tm, the height would be h. So the thing is, I got the thing, I'm going to use this for this. The thing is, you can use any equation and you can use any equation. After that, if you use this v is equal to u plus 80, you will be getting, you need to find the value of u, initial velocity. For that, you need to use v squared is equal to u squared plus 2as. And you need to use some other equation, v squared plus, I think v squared is equal to u squared plus 2as. And after that, you can find the initial velocity. After that, you can merge them. It's also very easy. It's not a difficult thing, but if you figure this one, you can directly use and get the answer at a minute. So if once I'm going to substitute over here, s is equal to ut plus half it squared, the s would be in the lowest direction. I'm going to put h because I'm going to take from that point to the highest point to lowest point. So h is equal to u is equal to 0, as I'm going to take only this portion, the initial velocity 0 in the vertical direction, half g Tm squared. So it would give the answer of 2h, root of 2h over g. A particle A is projected vertically upward from a top of a tower. So A is projected vertically upward from a top of a tower. So, At the same time, particle B is dropped from the same point. The graphs of distance, graph of distances between two particles varies with time is. I think they have given some graph over here. I think this is the graph, this is a item we should use for this one. Where is that? Yes. As shown in this figure, that means we have showed that figure now also. As shown in the figure, particle B is reached at point Q at time t1 and reach point T at time 2. So the image for the figure for this 59th question is given over here. So please try this one and send the answers for this question too. I think I have given 2 questions for you guys. You need to try it and mail it to the given address in the description. The lucky winner have a chance to win a big amount. Okay. Okay, let's continue this one. Particle A is projected vertically upward from the top of the tower. At the same time, particle B is dropped the same point. The graph of distances between the two particles varies with time is. So we need to find what's the difference between these two. So the distance, the thing over here is we need to know, we need to figure it out an equation, otherwise it will be difficult to do this. So over here, I'm going to tell the idea for you. You are going to try it on your own, and you need to send the answer for this question also. So over here, you can tell from the particle A, we are going to project it vertically upward from the top of that. So we are going to project this one. So let's say we are going to project with a velocity of upward velocity of B. At the same time, the particle B is dropped from the same point. So we are going to drop from the same point. I think it's not much difficult. So let's say we are going to drop from the same point. The graph of distances between of the two particles where the time is. So what's going to happen over here? So at the initial time, you can note that initial time it's going to go in this direction, and this one is going to move in the upward direction. What's going to happen over here is the distance is going to increase very fast because this is in the maximum velocity. So it's going to increase very fast, and this is going to go in the opposite direction. So it's going to have a very big difference. After that, what happens is it's going to, after it's getting the velocity of 0, it's going to chase it. However, the problem is, although it started to chasing, we can directly tell the velocity of this is very smaller than this one, which means it's going to have a higher velocity. So we can directly tell the distance is going to increase in that time too. So that the correct answer might be, for that 64 might be B, I think, according to my guess. It's going to be B. Wait, I'm checking. I think they have given A answer. So that the point is, we need, we can directly tell S is going to increase always. So it might be A or B. However, so that we can't directly actually determine using this method whether it's a linear method or it's going to increase in the linear method or it's going to have a curved graph. For finding that, you need to find the equations and solve them. So that's a better method. So I'm leaving this question for you guys and try to prove this one. They have given the answer A, so try to do it in your own and figure it out. Sometimes it might be B. So the thing we can figure it out is in the both consequences, in the both instances, the distance is going to increase. That's the thing. So try to figure the solve the steps for this question too. You need to get the equation and solve that and find the final answer and send it to my mail. I will note those questions in the, I will give the email in the description. Okay. A car is moving at a speed 30 meters due to application of brake. It travels 30 meters before stopping. Find its acceleration. So over here, you can directly use this equation. They have given the initial velocity u, and the next thing they are given the s 30 meter, and there's a hidden fact. What's that? The hidden fact is the final velocity is 0. So now we knew that initial velocity, we need to find the acceleration and the distance s and the final velocity. So according to these 4 variables, we can directly tell we need to use v squared is equal to u squared plus 2af. If you figure it out, you will be getting 15. But remember, you should have the minus, so the answer would be B. So it's not a difficult thing. We don't need to do that calculations too. You can directly get this one because it's going to decelerate anyway. So the next one. A particle moves with a constant acceleration 2 meters per second minus 2. Its initial velocity is 10 meters per second. Find velocity after t second. So a particle moves with a constant acceleration, its initial velocity. So they are given there's a constant acceleration. Find velocity after t. So if we know that one, you can directly use any equation and figure it out. The answer. Actually, you can use the graph method, any method, however, or you can use the integration and find some solution for that. Like we have already done that. So I'm going to use an equation method to find the answer. As it's a constant acceleration, we can use any linear motion equation directly. Sorry for that. Directly. So I'm going to use that one. So what equation we are going to use now? So that's the question. So we knew the value for constant acceleration a is equals to initial velocity, and we need to find final velocity after time t. So we can directly use v is equals to u plus 8t. So u would be 10 plus acceleration would be 2 into t. So 10 plus 2 into t, you can directly write as 2 into 5 plus t. It's going to be C. Answer for 66 is going to be C. Okay, let's move to the next one. Sorry. 67. A particle moves in a straight line with constant acceleration. There's a constant acceleration t is 10 seconds. Velocity and displacement of the particle are 16 and 39 meters respectively. What will be the velocity after 10 seconds? So here they are given. Actually, we knew that the acceleration is constant, so we can use any linear motion equation. Remember, you can only use the linear motion equation when the acceleration is constant. When the t time is equal to 10 seconds, velocity and displacement of the particle they have given the velocity and the displacement. Velocity is 16 and 39. What will be the velocity after 10 seconds? They are asking about that. Yes. After 10 seconds, might be they are asking about yes. After 10 seconds means we need to find it for 11 seconds, I think. Okay. Let's use the integration method for finding this. I'm not sure what to use that. So let's use the integration method over here. So they are given acceleration is constant. So let's make a is equals to c. Actually, we don't know what's the value of c. So if you use this next thing, if you integrate this a, you can use the linear motion equations too. But in the previous question, I have used that, so that I'm using the next method over here. So if I integrate this, I'm going to get v is equals to the constant c into t plus any constant, another constant. Let's say that's v, let's say v1. Okay. So if I substitute over here, the v1 would be, if we substitute over 16, velocity 16, And actually, we don't know what's the value of c. It's okay. Let's say this is 10c plus v1. So we can directly tell v1 would be equals to 16 minus 10c. Okay, like that, we need to find for this displacement too. I think this would be a little bit length method if we differentiate and substitute over the things. So I'm searching whether the linear motion equation would be very easy for this question. Let me try that one. So let's keep this one also. Sometimes if it's hard, we can directly jump into this one also. Okay, try it in both methods, guys. Okay, if I try this one, at the 10 seconds, actually we knew the velocity 16 and 39 s. There is 39. The velocity, final velocity is particle displacement. They are given that there's a constant acceleration. So let's use v is equal to u squared plus 2as. However, we don't know what's the value of u squared. Not a problem. So if I use the use here, if we use this one, how to find the other values? That's a question. Actually, we need to use this 10-second too. So let's use this one. First of all, we try to find the initial velocity. How we can find that? We can use this equation, s is equal to v plus u by 2 into t. Actually, we knew the value for s, which is 39, and 10 seconds, so I'm going to divide it by 10, is equals to v plus u. V is going to be 16. Initial velocity, we actually don't know what's that, and 2. If we simplify this, it's going to be 5. 39 divided by 5 would be 7.8. So u is going to be 7.8 minus 16, which means we are going to get the answer in minus, which means it's in the negative direction. In the, let's say it's in the left side. Not a problem. So from that, we can find the value of u. So after that, we need to find the acceleration. So how we can find that is, we can directly use v squared is equal to u squared plus 2as. Actually, we knew the value for v. We can find the value for u using this method, u squared plus 2 into, actually we knew the value for s, displacement, and the acceleration can be found using this. After that, we need to substitute. We can directly use for v is equal to u plus 8 equation. At that equation, actually we knew the time. We need to use t is equal to 11, and after that, we knew the value for u and a, so that we can find the velocity of v. Try it in your own, guys, and leave the answer in the comment box. Hope you can do it easily, but the thing is, you need to do some further calculations to figure it out, and try to do it in the next method. The first method too, it might be a little bit lengthier, but try it. Okay. A particle moves with a constant acceleration 2 meters per second minus 2 in x direction. The distance traveled in 5th second is 19 meters. Calculate the distance traveled after 5 seconds. So here, a particle is moving with a constant acceleration. They are given the acceleration to 2 meters per second minus, 2 meters per second square in the x direction. The distance traveled in the 5th second is 9 meters. So they are given the the distance traveled in the fifth direction on fifth second only. So we can use the equation directly, or you need to figure that equation again and use it for this time. Calculate the distance traveled after 5 seconds. So over here, we need to figure it out. What's the distance it has been moving? Okay, the distance traveled. So over here, what we can use directly is, actually we knew what's the distance traveled in the fifth direction and the acceleration. Let's say so they haven't talked about the initial velocity, so let's take it as u. If you need any variable, don't scared to take that variable, so scared to name that variable, just take it, and finally you will automatically cut down that one. Okay, let's take this as u. If I take it like u, what I'm getting is, yes, in the fifth second, for the total 5 seconds, we can write it like x is equal to u plus 80. If I write it like that, is x is equal to 5u, I'm going to replace this t by 5u plus half into 2, so it's going to be 1 again, t squared would be 25. Likewise, I'm going to write another equation. It's going to be s minus 19, because in the fifth second, we knew that it's going to move for 90 meters. So we can directly tell at the fourth second, if the total distance covered for all 5 seconds is the total distance covered in the all first 4 seconds would be s minus that 19. The total, the 19 meter is covered on that fifth second only. So if we deduct that, we can directly get this one. So we can directly write s minus 19 would be equal to 4u plus 60. So I'm going to deduct this one from this one. If I deduct this one, I'll be getting plus 19. If you deduct 5u minus u plus 25 minus 16 is going to be 9. If I simplify this, I will be getting u is equal to 10. So the thing over here is, now we have found the value for 10. So what we can do over here is, actually we know the value of for u. If we substitute over here, 50 plus 25 is going to be 75. So this is going to be 75. So the total distance covered would be 75. The answer would be B. Let's check with their answers. Wait a minute. T65. They have given us C. Is it right? Yes, it might be, because they have given what's the distance traveled after 5 seconds. So if you consider another second, let's say, let's consider that 6 seconds, what would be the results? Let's check that. 5 into 10, sorry, 6 into 10, 60 plus 6 into 6, 36. It's going to be 86, sorry, 96. However, I think that after the 5 seconds, which means in the total 5 seconds, we can tell the 75 meter will be covered. After that, we can calculate there's only one answer, it's going to be 80 meter. So that's the final answer for 68. So sorry, I think I am making a mistake again. They have given the answer B, then that's right. They're asking about the total distance covered in that 5 seconds only. So we need to find the total distance covered in that 5 seconds. So you can directly use this one. I think in the sense, we can tell there's a little bit wrong on this one. at t is equal to 10 seconds, they have already given the velocity of that particle. What will be the velocity after 10 seconds means they are going to ask the same thing. Velocity at 10 seconds. So there might be a wrong. Please try it and let me know. Okay. Two bodies of masses M1 and M2 are dropped from heights h and 2h. The ratio of time taken by the body of touch the ground is. So they are given the masses. The main thing is the gravitational acceleration doesn't depend on the mass of a body. So we can directly tell it's similar to those two things. So we can tell the acceleration for these two bodies is going to be same. So if I consider these two, the initial velocity would be 0, that we are going to drop these two. So we can directly tell the initial velocities of these two will be 0. So we can directly use S is equals to half gt squared. And g is also going to be the same. So we can directly tell S is proportionate to t squared. In the first one, we can directly tell h is proportional to t squared. In the second one, we can directly tell 2h is proportional to, let's say this is t1 and this is t2 squared, proportional to t2 squared. If I divide 1 by 1, I'll be getting t1 over t2, whole thing squared would be half. So if I take the root in both sides, I'll be getting t1 over t2 would be 1 over root 2. So the answer would be C. A freely falling stone crashes through a horizontal glass plate at time t and loses half of its velocity. So for that, a freely falling stone crashes through a horizontal glass at a time t. Okay, and loses half of its velocity after time. Okay, it has lost its velocity by half after the time t by 2. It falls on the ground. So first of all, it has taken t seconds for reaching that horizontal glass. After that, the velocity has been dropped by half. It has taken t by 2 to fall on that ground. The glass plate is 60 meter height from the ground. So this is the equations you need to use. So there's a glass plate over here, which is 60 meter above. And we can directly tell it has taken t by 2 time to travel over here. And actually we knew for this upper part, it has taken only t seconds. And they have given find the total distance. So actually we know that as this is, if the velocity is 0 in the beginning, it's going to be v over here. Actually, we don't know what's the velocity over here. However, we can find, we can directly tell it's going to be v by 2. So these are the things they are given in this question. So we need to use all the things to figure the answer. So in the next part, in the second below part, we can directly tell we knew the value of initial velocity, time, and the distance. So if we consider this, we can directly tell we need to use s is equal to ut plus half at squared. As we know the s, we can directly write it as s 60. U, the initial velocity is v by 2. So I'm going to write it as v by 2 and time is t by 2. So we can directly write vt by 4 plus half gt squared. G is equal to 10. So we can directly write 5 t squared by 4 because of t is equal to t by 2 over here. T squared by 4. So this is the equation. Likewise, for this part, we need to find the distance d. So for this section, for the upper section, I'm going to use the same equation. D is equals to, the velocity is, the initial velocity is 0. That's a good thing over here. 0 is equals to, there's a problem over here, I think. Let's solve that. So half t squared, so this we can write it as 5t squared. However, it's not enough because we haven't used this data. If you have given any data, please make sure that you have used all the data they have given. So we haven't used this p part. So how we can use this is, we can use any other equation. B is equal to u squared plus 2as over here. If I use that, I will be getting b squared, u squared is 0, is equals to 2 into 10 is going to be 20. So now we have three equations, 1, 2, 3. But the task is the same. We need to find the answer for D. So what we can do is, let's substitute. So here we have how to check whether these equations are enough or whether we need any other equations to find the answer. That's a simple thing. You need to count the whole equation. There are three equations, and count how many unknown variables you have. Actually, we don't know the value of V, and the next one is T, the next one is D. There are three unknown variables. If these both are equal, the amount of these both are equal, you can directly check these equations are enough. So from that, we can directly tell these equations are enough. So we can start to solve this. So if I use this one, this d by 5 for this t squared, I'll be getting, we can write it like d by 4 over here. Likewise, I'm going to substitute over here. We can practically tell d squared is equal to 20d, which means v is equal to root of 20d. Okay. Likewise, if you use this d is equal to 5t squared, if you substitute t over here, it's going to be d by 5. D by 5 over 4. If you simplify this, it's going to be 4d squared, root of 4d squared. If you take the root, you can get 2d over 4. So if we simplify this, you will be getting d by 2 plus d by 4 is equal to 60. If you simplify this again, 2d, d, 3d, 3d by 4 is equal to 60, 24, 80. The d is equal to 80, but be careful, they haven't asked about this d. They're asking about the total distance traveled by that. So be careful of the question. So if you add this 60 with that, it's going to return the answer of D. The 70 for the answer for the 70 would be D. Be careful. Okay. A freely falling object travels distance h, its velocity is v. Hence, in traveling for the distance of OH, its velocity will become. So here you knew the initial velocity is 0 because there is a freely falling object. So 0 and the traverse distance would be h. Its velocity is v. Hence, it's traveling for the distance of 4h. So over here, the problem is it's going to travel for the distance of 4h from this h, which means the total distance would be 5h. So be careful of that. It's not a difficult question, but there's a tricky part. From this part only, it's going to move another 4h. So when you are using x is equal to ut plus half h squared over here, as we know the value of 0, we need to find the velocity of v. So it's better to use v squared is equal to u squared plus 2as, I think. As if you use this v squared plus u squared plus 2as over here, and in this portion, you will be getting the answer. So I'm not going to elaborate that. You can directly use v squared is equal to u squared plus 2as. So for this one, after that, you need to use v squared plus u squared plus 2as for this total thing. The thing over here is, the main important thing is, you need to check whether you have get the correct displacement. You need to use 5h over here because it's traveling further distance of 4h. It's a little tricky part in this question. Okay. Okay, we'll move to the next one. Okay, the ball is thrown vertically upward direction, neglecting the air resistant velocity of the ball in air will, what would happen? Actually, we knew that if we neglect the air resistance, initially it will decrease. But when it reaches the minimum velocity, which is zero, after that it will going to return, and the speed of that ball is going to increase. So the correct answer would be decrease when it's going up. Oh. Two particles P and Q get 5 meters closer each second while traveling in opposite direction. They get 1 meter closer each second while traveling in the same direction. The speed of P and Q are. This little bit interesting question. So over here, they have given P and Q. Let's say the velocity of P is V1 and PQ is V2. What's mean by the velocity? You can directly tell that the distance or this displacement in this side, you can directly tell distance also. The distance traveled in 1 second, traveled per second, because we are dividing the distance by time. So we can directly tell the distance traveled within that 1 second. So we can directly tell in the 1 second, two particles are close each second. So in a 1 second, the two particles will have, let's say, they are in the same, in these two position. It's going in 1 second, it will move this V1 in this direction. Let's say this is P. And let's say this is, they are telling about they are moving in the opposite direction towards each other. Okay. So here they have mentioned it's going to move in 1 second, it's going to move V1 distance, because actually we knew that what's meant by the velocity is the total distance traveled in 1 second. So if we cross multiply this, you will be getting the distance would be V into T. The T is 1, so we can directly tell the distance would be V1. And this Q would move towards this one, V2. From this, we can directly tell V1 plus V2 would be 5. This is the distance which they get closer. One gets some distance and another one gets another distance, but the total distance would be 5 meters because they are getting 5 meters closer. Likewise, if they move in the opposite direction, the same direction, let's say it's going in this direction, you can directly tell they get 1 meter closer. So if you take this is as for getting 1 meter closer each second, you can directly tell the first one should be slow velocity and the next one should be a little bit higher velocity. If you use this, actually we don't know whether V1 or V2 is higher. Let's assume that V1 is highest. So if I throw the V1, it's going to get 1 meter closer, which means V1, it's going to move V1 in a second. It's going to move only V2, a little bit smaller than this. So that is going to, the distance is going to reduce by only 1 meter. So we can directly tell V1 minus V2 would be 1. So if you simplify this, you can directly get V1 is equal to 3 and V2 would be equals to 2. So after that, you can directly simplify. Try to imagine this, otherwise it would be a little bit difficult to figure it out. Okay, next question. Motion of a particle is described by an equation V is equals to something, where V by A are velocity, distance, and a constant, respectively. So A is a constant, Y is distance, and V is the velocity. Find the acceleration of the particle. So over here, for finding this one, you need to differentiate the thing. So over here, the motion of a particle is an equation. So they have given the equation directly, but they haven't given any other ideas over here. So finding the acceleration, anyhow, we knew that we need to differentiate. So if we differentiate this equation, we'll be getting, if we differentiate V, we'll be getting directly A, acceleration. And the other sign is in the negative sign, in the root. So if you differentiate the root, you need to know how to differentiate the root. It's going to be 1 over 2 root 8 plus y into, if you differentiate y again, it's going to be this way. So I think if you do the differentiation properly, you will get the answer in 2 steps. So if I differentiate this, I will be getting a. Remember, if you are differentiating a root, it will return another root like this one, 1 over 2 root of this value, a plus 1. Into, if I differentiate this y part again, actually y dot would be v, velocity. So I can write this part again. As this is a velocity, I can write this part again. It's going to be a plus y, root of a plus y. So I can tell this is going to be cut down. So the answer would be half u. The minimum distance in which a car be stopped is x. The velocity of the car is v. If the velocity is 2v, then find the stopping distance. So the minimum distance in car which a car can be stopped, the minimum distance they are given. I need a minimum distance x. Within the minimum distance x, it can't be stopped. The velocity of the car is v. If the velocity of if the velocity is 2v, then find the stopping distance. The thing over here is, in the initial velocity of when the initial velocity is v, the car can be stopped at x direction, x distance. If the velocity is v, the car can be stopped at x distance. So, however, they are going to increase the 2v, the velocity of 2v. So, how long it will take, or how much distance it will take, how far it will take to drop that. So, let's say this the velocity is 0 and this is 0. So, actually, we don't know what's the distance, so let's make it as y. So the thing you need to remember, or you need to consider about this one is, there's a hidden fact: the acceleration is going to be same because they are going to use the same brake. The maximum brake, the maximum force, friction force, or the maximum force which can be produced to stop this car is going to be same. So we can directly tell that the force is, as the force is going to be same, the mass is also going to be the same. So we can practically tell the acceleration is going to be the same. So in these two models, we can practically tell the maximum acceleration. In the other terms, we can tell maximum deceleration. The maximum deceleration would be same for these two instances. So you need to use v squared is equal to u squared plus 2as over here, and you can find the maximum deceleration. Likewise, you need to substitute same maximum acceleration, so deceleration over here, or minus acceleration or negative acceleration over here, and find the answer of x. Hope you can do it in your own. Another milestone we have reached now. We have completed up to 75. Okay, let's continue. A particle moves in one direction with acceleration 2 meters per second minus 2 and initial velocity 3 meters. After what time its displacement will be 10 meters. So they have given the acceleration as well as the initial velocity, which means the velocity is going to change. Sorry for that. After what time its displacement will be 10 meters. So they haven't mentioned about what's the initial displacement. So from that displacement, we can take with the initial time, the displacement is 0. And the initial velocity is 3 and the acceleration 2. So how we can find this one? So we need to find what's the equation we can use for this one. Actually, we knew the value for s, and we need to find the value for t. And the next one, we have the value for initial velocity and acceleration. So the answer would be s is equal to ut plus half at squared. If you use that, you'll be directly getting the answer of 2. Next question. Okay. A good train is moving with a constant acceleration. When engine passes through a signal, its speed is u. Midpoint of the train passes the signal with speed v. What will be the speed of the last wagon? So there's a good question. Interesting. A good a goods train, oh, wait a minute. A goods train is moving with constant acceleration. So what's happening over here is, when we are considering about this, the train is going to accelerate. But here they haven't mentioned what's the time taken or what's happening over here. Actually, we knew that when the engine is in the speed of b, the whole body part is going to have the same velocity v. So that's the thing you need to note here. So let's try to imagine what's going to happen over here. Let's say it's at the t is equal to t, it's in this line over here. Think like this one. This is the middle part and this. Okay. So let's say this is length L and this is length L, and the initial velocity is going to be v at t is equal to 0 at this one. Time passes it junction. So in this case, we can directly tell the middle part is going to be in this side, which means this is going to be L again, and this velocity would be u, because they have mentioned about this one already. If the part of a body is having the velocity, the other parts of the velocity, the body is also having the same velocity in the train. So that's the trickiest part in this question. Likewise, they are asking about the speed of the last wagon. So if I draw a line like this, last wagon, which means the 2L shall pass this point, and they're asking about this velocity. Let's say this is v1. So over here at the initial point, if you consider like a particle at it's having a v velocity, wait a minute, let's consider this is a v velocity. After that, it's moving L distance and with having a u velocity. After that, it's having 2L, totally it's having moving 2L distance, and we need to find the velocity of this. So you can use some equation for finding this L. How to use this one is, actually we don't know what's the acceleration over here. So let's use v squared is equal to u squared plus 2as. If I use this, I'll be getting u squared is equals to the final velocity is u squared over here. U squared is equals to v squared plus 2a. The s would be displacement would be L. Likewise, we can use for these two also. These 2 points. If I use these 2 points, it's going to be final velocity would be v1 squared. We need to find this v1 squared is equals to initial velocity would be v squared again plus 2a into 2a, which means 4a L. Why is that? The total displacement would be 2L. So if you consider this, you can directly substitute u squared minus v squared over 2L. If you use this, you'll be getting v squared plus 2 into 2L. So we are going to write 2 into u squared minus, oh, sorry. This is the u and this is v. So we need to change it like this, u, and this is going to be v. So this is going to be u, this is going to be u. So we can write like v squared minus u squared. If I simplify this, I'll be getting the d answer. So over here, the trickiest part is it would be difficult if you think about the train. You need to think as a particle and consider what's the distance the train has moved on or moved away. Okay, let's move to the next one. Displacement of a particle in y direction is given by y is equal to t squared by minus. Okay, that is in a second. Calculate the time when its velocity is 0. So here they have given the displacement in that y direction. Nothing to worry about that. It's going to move in this y direction, in the x direction, and if you consider the y direction, that we are going to consider in that y direction. Okay, fine. So we need to differentiate that according to that time, relative time. After that, we need to use that y dot is equal to 0, which means we need to use 0 for that velocity. So if we do so, we will be getting, if we differentiate that, we will be getting 2t minus 5 is equals to velocity. When the velocity is 0, we can calculate 2t minus 5 is equal to 0. From that, we can tell t is equals to 2.57. Okay, next. The area and the acceleration versus time graph for any time interval represents. So they have asked about this one, the area and the acceleration versus time graph for any time intervals. We have already discussed many times, repeating. So if we do so, we will be getting the change in velocity in the time interval. Don't forget that. Sometimes if you see the velocity, some might answer BOA. Remember, it will give the change in velocity. Okay. A ball is thrown vertically upward. What's the velocity and the acceleration of the ball at maximum height? Actually, we knew that when we throw a ball, it's going to have only the gravitational acceleration if we neglect the air resistance. So that we can directly tell the acceleration is going to be g. And the next thing over here is it's not going to be changed. Okay. And the maximum, at the maximum height, the velocity would be 0. After that, only it can return to the original point. So we can tell the velocity is 0 and the acceleration would be, they are considering about the upward direction. They are mentioned that it's going to throw the ball in the upward direction. So the answer would be minus g. There's a little mistake. It's going to be g and minus g because of they have measured that gravitational acceleration in the upward direction. So we need to use the minus g. Okay. 81. The relationship between velocity and the position of a particle v is equal to x degree where a and b are constants. Here, acceleration of the particle is 10 meters per second minus 2 when its velocity is v. How much is the acceleration when its velocity is 2v? That's the question. So over here, actually, we knew that how to find this one. Then you need to find this acceleration from the velocity. We need to differentiate that. So if we differentiate that, we'll be getting acceleration would be equals to a constant. So we need to write this again, a. And if you differentiate x, it's going to be v. So we can directly substitute. We knew that when the acceleration is 10, when the velocity is v. So we can directly tell when the velocity is v, we don't know the constants. Let's say that a is 10. They are asking about when the velocity is 2v. So if we substitute 2v over here, and the a is going to be remain the same, we need to find what the a. So we can directly tell. Actually, we knew that AB is going to be 10. So 2AB would be equals to 20. It's not a difficult mathematics. Hope you can do it easily. Okay. Okay, in the next question, a particle moves on a plane along the path y is equals to ax cubed plus b. So here they have given to relationship phi is equal to ax cubed plus b in such a way that dx over dt is equal to a constant, which means in the x direction, the velocity is going to be a constant. So the question over here is we need to find the acceleration of this particle. So how to find this one? They are given dx by dt is c. Be careful. C full stop, the sentence over here. After that, C, A, B are constant as a concept. Okay. If you consider this, actually we knew that y is equals to ax cubed plus b. So they are given that dx by dt, so we can quickly tell we need to, which simply means in the x direction, the velocity is going to be constant. So we can correctly tell in the x direction, the acceleration is going to be 0. But it doesn't mean in the y direction also the acceleration is going to be 0 because we have some function. So we need to we need to solve this and find the answer. If we differentiate respective to time, we'll be getting dy by dt in the y direction. Dy by dt simply means in the y direction, what's the velocity? Actually, they are given the velocity of the particle in the x direction, but they haven't given for y direction, but we can get it by differentiating this equation. If we differentiate, we'll be getting 3ax squared into dx by dt. They are given it's a constant c, so I'm going to replace over here. So 3ac over 3ac to x squared plus b. If we differentiate b, it's going to be 0. Okay, fine. After that, we need to find the acceleration. So we need to differentiate it again. So by double dot, I'm going to write it as y double dot means we have differentiated by 2 times respective to same variable time. So if we do so, we'll be getting 6 a c x. Not only that, we need to use x dot again. We need to differentiate x again, because we have differentiated x relative to t. After that, x squared relative to x. After that, we need to differentiate x relative to t. If we do that, we'll be getting x dot. So be careful about this one. Actually, we knew that x dot is going to be c. We can directly tell it's going to be 6 a c squared x. I think I have made a mistake over here. 3x squared. So this is because it's in the y direction. So you need to put this j sine 2. I mean, let's check whether it's correct or whether we have made a mistake. We have given it's going to be 3ac x squared. We need to differentiate again. If we differentiate, we'll be getting 3ac. If we differentiate 2x squared, it's going to be 2x, 6ac x, and it's going to return x dot also. So if you see this x dot, we need to use this c. If you use that, you'll be getting 6ac xc squared, which means it's going to be 6. I think for 82, they have given what's the answer? They have given, okay. Okay, I think they have mistakenly put that answer. It's going to be 6. Be careful, it's in the y direction, so that we have denoted by j vector. However, in the I direction, in the x direction, it's a constant velocity they have given, so that we can directly take the acceleration would be 0 in the x direction. So the answer would be B. You need to change it for 6. Okay. Okay, I'm going to give another surprise question. This is also 83. Yes, you need to solve this and find the answer for this question also. So up to now, I think I have given 4 questions totally. There is one more question. I'll give it in a rapid discussion. Okay, next one. An object moves in xy plane. Equation for displacement x and y directions are x is equals to 3 sine 2t and y is equal to 3 cos 2t. Speed of the particle is. So the thing over here is they have given in these 2 directions. One is 3 sine 2t, and in the y direction, the displacement is y cos 2t. So first of all, we need to find what's the velocity in each direction. First of all, we need to find that. So how to find the velocity in the x direction? You actually knew that we need to differentiate once. If we differentiate, we can get the velocity in the x direction. It would be x dot would be equals to 3 into 6 cos 2t. Likewise, we need to use for y direction also. If I use this for y dot, it's going to get 3 to 6, but minus 6 sine 2t, which means individually they are having t components again and again. So, but the question is, we need to find the total speed. We have now found in both directions individually, so we need to combine this. Let's say in this direction is s dot, And this y direction, as it is minus, I'm going to denote in this direction. This is going to be 6 sine 2t. And in the x direction, it's going to be 6 cos 2t. So if I take these two, the final velocity, you can easily figure it out. It's going to be the vector addition of these two would be as it's a right triangle, you can directly take the square root of these two and take the root. If you do so, you will be getting 6 root 2, I think. 6 squared cos square 2t. No, you will be getting 6 again. 6 squared cos square 2t plus 6 squared sine square 2t. You need to add up them. If you add up them, you will be getting 6 squared. You need to take the root, you'll be getting 6 value. So the speed of the particle would be 6, so that you can recognize it's a constant and a non-zero element. Okay, be careful of this. They are given in both directions. It would be a little bit difficult than the previous one. Okay. Motion of a particle is prescribed by x is equal to t minus 2 square. The beautiful thing is now we are going to consider in one direction. That's a beautiful thing. Yes. Find its velocity when it passes through origin. So here we need to find the velocity when it passes through its origin. So before that, we need actually we can plot a graph in a way for finding this x displacement time graph. After that, we can directly tell that. Otherwise, we can tell, actually, we can try this method. We can find the equation for velocity by differentiating that. After that, we can substitute the time 0 for that and find that value. So I'm going to do that. If you wish, you can draw a graph for x is equal to t minus 2 squared. From the gradient, you can directly find out that. So if I differentiate this, I'm going to get x dot is going to be 2 into t minus 2. Yes, this is the velocity. So the question is, so yes, 2 into t minus 2, if we differentiate t respective to t, is going to be 1. So that's the answer. So we need to find what's the velocity when it passes through origin. Origin means the time is equals when the time is equals to 0. So when you are considering about the time is equals to, the problem is how to find this order. What they mean by this origin is whether they are asking about the x over here. So a little bit of confusion. Yes, here they are mentioning about the origin point. We knew that the origin point, the basic origin point is the point, the reference point, like the reference point where we have started to measure the length from that point. So we can tell the x is equal to 0. That's the origin. Don't think about the graph, just the point where we are going to start the measuring. So x is going to be 0. So if you substitute over 0 over here, you will be getting t is equals to 2. Yes. If you substitute the t is equal to 2 over here at the time 2, you will be getting x is 0, which means it's going to return to the same position, the origin position. So we can directly tell, if you substitute over 2 over here, you'll be getting, it's going to be 0. The final answer will be 0. So a little bit trickier, but not much. Okay. To introduce a vector quantity, actually we knew that it has both magnitude and direction. Always a vector quantity should have these two. Okay. Which pair of two vectors is anti-parallel? So what's mean by this parallel and anti-parallel? Pair of two vectors. So we need to find that pair of two vectors is anti-parallel. So okay, parallel means, you can directly tell, parallel means the phase difference would be 0, which means if it's in this direction, then another vector is also should be in this direction parallel. which the distance between these two lines won't change. Likewise, the antiparallel means the line distance won't be changed. However, it's in the opposite direction. As we need to consider the direction, it's going to be opposite. It's also parallel, but we are going to give it a special name, anti-parallel, because of the directions are different. Not a big deal. If you knew that a definition, you can really figure it out. In the above figure, P and Q are two vectors, but from following is true. The first question, P and Q is equal. Definitely it's not, because they are in the opposite, they are in the right hand direction, so you can't tell like that. P and Q are anti-parallel. No, we can't tell like that, because P is in this direction and Q is in this direction. So that's not anti-parallel, okay. And this is in the same direction. That's not true. They are in the opposite perpendicular direction, so this is the correct one. It's 90 degrees. From the following is a scalar. So when we are considering about the scalar, acceleration, velocity, and electric field, oh, there's a little bit a question whether the electric field is a scalar. No, electric field is a vector. Electric field intensity is a vector. So we can tell electric current would be a scalar. Wait a minute, let's check the answer. So yes, the answer is electric current. But there are some contradictions, and there are some, if you ask in some syllabus, they might have the electric current is also a vector. But the thing over here is, in the electrical engineering, we normally use the vector addition for current too. So don't think too much. However, in this case, according to your syllabus, you can practically tell the electric current is a scalar. Actually, we can make sure that other three are already vectors, so that we can directly come for 89 is equal to, they are given the answer of A. So we can directly get the answer electric current. P and Q are equal vectors, but from the following is true. Remember, when we are telling about the equal vectors, the vectors have two parameters. One is magnitude and the second one is direction. So the both should be same to tell that equal. So we can directly tell the P and Q are parallel, as well as P and Q have the same magnitude. So according to that, you can directly tell the B is the correct one. Sorry for that. Okay, 19th question. Yes, the next one is also the same. The P vector is Q vector is if their magnitudes are equal. Yes, the magnitude should be equal. Yes, they are in the same direction. Yes, that's also correct. The magnitudes are equals and they are in the same direction. That's the main point. You need to compare the magnitude as well as the direction. If the magnitudes are equal and the directions are in the opposite side, you can't tell these two vectors are equal. So not this point. When you are comparing the vectors, you need to remember that you need to compare these two. Yes. A and B are in opposite direction. So they are, you can directly tell they are anti-parallel vectors. Just previous question only we have discussed about that. If they are in the opposite direction, which means we normally use the opposite direction when there's a phase angle of 180. If this is in the equal direction, and if you change the 180 degree, it's going to be opposite direction. So you can directly tell it's going to be anti-parallel. 93. Calculate the angle between a vector and y-axis. So over here, you need to memorize this formula, the cosine, the direction cosine, most probably you will already learned about that. Yes, if you having this doubt, I have given some reference link over the description. You can always watch that video too. If you need to find the cosine directions, you need to use this equation. Cosine, I'm going to find this for y direction. So cos beta would be equal to, you need to take the coefficient above this y direction is 2j. So I'm going to take this 2 over. After that, we need to find the root of all three. 1 squared plus 2 squared plus 2 squared, which will return to 4489, which will equal 9, and we will get the answer of 2 by 3. So the answer is cos inverse 2 by 3. Oh, most of you will stuck in this one. So there is no answer. The question is wrong, right? So don't take the decision, but the answer they are given in the sign too. So you need to check the answer in the signs too. The concept, most probably you will all know this concept. When you are doing it, that exam condition, you might have some tension. Not you, I also have that tension when I'm doing the exams. So at that time, you need to think about it. They are given in the sign too, so you need to check that answer too. So when you are using the Binders theorem, you can directly find the sine theta. Let's say this is 2 cos, let's say this is 2 and this is 3. If there's a 3, this is going to be 339 minus 4, it's going to be root of 5. From that, you can tell it's going to be root 5 by 3, it's going to be this one, sine inverse root 5 by 3. Be careful about this. A and B are non-zero vectors, which from the following are true. So I have already mentioned, I like to leave the fixed question for you guys. You need to try this on your own. Before that, I'm going to give a little bit idea about that. You can use it directly, use this equation directly, but I'm going to show some methods or a graphical representation of this idea. So let's say there's a vector in this direction, and there's a b vector in this direction. Let's say this. So what's mean by this? A plus b is this. This is mean by a plus b. A minus b means we are going to take the equals magnitude vector from this point to negative side, the negative direction with the same line. So this is going to be 10. Sorry, it's not 10. It's going to be the same, but in the opposite direction. If you consider these two vectors, it's going to be a minus b is going to be in this direction. So this is known as, this is a plus b. This is a graphical representation. So you can use this also. Otherwise, actually, most probably you knew the equation for these two, a plus b. How to find this? You can use either this or this. Let's say the angle is theta. This vector is a, magnitude of a. This is magnitude of b, mod of b. I'm going to denote it in the simple letters a and b. You can find this angle. Let's say this is theta. It's using cosine rule is root of a squared plus b squared minus 2ab cos theta. Using this one, you can write this one. Likewise, this is going to be pi minus theta. So using this, you can write this for this equation. After that, if you simplify this, you can get whether it's going to be a squared or b squared or anything. So just write down. Also, you can either use this graphical method and find the geometric cosine. You can use the cosine rule to figure it out, or you can directly use the answer, use the direct formulas you have already studied. So they have already mentioned over here. Wait a minute. Yes, they are given. Oh, sorry, they haven't mentioned about this one. So I think that method would be easy for you guys. If you have any method, please try it in your own and send your answer to that email. So I think I have given 5 questions for you guys. Okay. The 95th question, C vector is equals to a plus b vector, but they are given the magnitude of these 3 are equal. Yes, that's great. find an angle between A and B. So how can we do this one? So in some times you have studied in this direction. You can write in this formula too. You can use C, A, B. These are the same, but you can use this notation too. You can use the simple letters, and under that letters, you need to use an underscore for denote that is a vector. The magnitude of this would be CAP. So how to find it? You can directly find this by having a dot product in both sides. If I have a dot product, C dot C would be A dot, A, so I'm writing very slowly, sorry for that, into dot A dot B. This is a method you need to know that, otherwise it would be difficult to solve this question. So if you knew that when you multiply, when you're having the dot product between two vectors, two same vectors, you will be getting on 1, because it's going to, you are going to get the value of mod of c squared, which means the value of this one, c squared. You can directly use this as, because it's going to give c dot c would return c into c into cos theta, as the theta would be 0, as these are in the same line, as these are the same vectors, you can tell these are parallel. So theta is going to be 0, so it's going to return c squared only. Likewise, if you simplify this, you will be getting a dot a. A dot a means it's going to be a squared. If you do the cross product between b dot b, it's going to be b squared. After that, if you dot product with AB and AB, it's going to be 2AB. 2A dot B dot. If you find the A dot B dot, we can find the angle between them. However, if we already knew that, it's going to be mod of A, mod of B. Mod means the magnitude, I'm meaning the magnitude. So AB and that angle cos theta. Actually, we knew that A, B, C are equal. So if you substitute all the things by A, and if you simplify this, you will be getting the answer for cos theta. It's not a big deal. You can figure it out. The next question. The resultant of two vectors is maximum when they are, you can easily figure it out, when they are in the same direction, it's going to be the highest value. It's not a big deal. And the next thing is, it would be the minimum if they are in the opposite direction. So if they ask to find whether the resultant vector can be this one, if they give some vector, the values of the vectors, and ask whether these vectors can be the resultant of any two vectors, you can figure it out by adding those two vectors and deduct one from that, seeing the difference of these two vectors. I think there's a question like this one. Wait, we'll check. The resultant of two vectors, yes, that's the question. Okay. The resultant of two vectors cannot be smaller than A minus B, because the minimum of two vectors can be obtained when these two vectors are in the opposite direction. So if you take like this, it's going to be A minus B. The resultant vector would be in this direction, A minus B. So it can't be smaller than this one. So that's the thing over here. A minus can be smaller? No, it cannot be. It can be greater than A plus B. No, it can't be, because the maximum resultant will be obtained when these are in the same directions. So we can tell the maximum would be A plus B. So it cannot be greater than. So from that, you can tell it's going to be can't be greater than A plus B or smaller than A minus B. So that's the answer. Likewise, the resultant of two forces, sorry for that. The resultant of two forces of magnitude 2 Newton and 3 Newton can never be. So this is the question I wanted to answer here. You need to find, they are given some vectors, there's some values, and they are asking whether the resultant force of these two can be 4, 1, 2.5, but they are asking whether this vector can be satisfied. Never be. So we need to find the maximum, which is 2 plus 3, 5, and deduct 1. It's 3 minus 2 is 1. The difference between these are 1. So the resultant vectors can be from 1 to 5 only. So if you see 4, that can be 1, that can be 2.5, can be 1, half cannot be. So that's the final answer. The sum of P, Q is at right angles to their angles to their difference. Then is going to be set right angles to their difference. Oh yes, they're asking about let's say the sum of PQ is at right angles to their difference, which means when we are considering about the P plus Q vectors, if we add them, it's going to return the answer. The P minus Q would be a right angle to this one. They are having this. You can use many methods. You can use the equations too. But if you draw a graphical method, it would be a little bit easier for you. So how to do this one? Let's say this is P. Actually, I don't know what's the P. Let's say this is Q. So likewise, if we draw like this is a minus Q in the same direction. So this is would be 90 degrees. So I think this would not the equation. So here, this is plus Q. If we take in the negative side, it's going to be P minus Q, and this is right angle. So this is minus Q. This is going to be P plus Q vector. And this is going to be P minus Q vector. So the question is, we need to find, this is not A, B, they should give in P and Q. So we need to find what's the relationship between P and Q. Now, how to find this one? Actually, we knew that this angle, this side and this side, we are going to use some geometry. So this side are equal. This side and this side are equal because they are Q. And we knew that it's going to make 90 degrees with this one. I think you have already learned about this theorem or law, which states that in a diameter can make a point in a circle with 90 degrees. Let's consider this is a circle. This should be a circle. As this is these two are same lengths, and this is making 90. This is going to be a circle. From that, we can directly tell if it's a circle. We can tell that this is going to be a radius. This is going to be a same radius. So this we actually marked it like P, but we can directly tell now P is going to equals to Q. From this graphical method, you can directly tell P is going to be equal to Q. The next question is, magnitudes of A, B, C are 41 and 49. Yes. A is equal to B plus C. Find the angle between A and B. So here, we can use the same thing over here also. At the last time also, we have used the same method. A is equal to B plus C. Take the dot product between these two. But the main part over here is, if you take the dot product directly, A dot B like this thing, you will get that the angle between B and C. But they are asking about the angle between A and B. So what we can do is bring that to the next side, A minus B is equal to C. After that, do the same dot product. you will get the answer easily. It's not a problem if you take the answer for B and C, but you need to draw a triangle after that. Let's say this is A, this is B and C. If you get this angle, you can always find this one using sine rule, but you need to do another step, additional step. If you use the dot product between these two, let's say you need to have dot product in the same side, C dot C, in C side, A minus B dot A minus B. So if you do so, you can directly get the answer. Otherwise, it would be a little bit difficult. You need to find this again and use the sine rule. After that only you will be getting the answer. The main thing over here is that at the time we have completed 100 questions. Very happy to announce that. And there are more questions too. I hope you can try this in your own. They have given the answer in the description. Sorry, they have given the answer in the back part. If you have any doubts, please comment below. And thank you for studiestoday.com. Otherwise, I need to make a paper for this one. So they have made my time useful. Okay, I hope this video would be useful for you. If you have any suggestion, please leave it in the comment section. And I hope we will get better in the future to study well. And we will try to upload many videos as soon as possible. And there might be many mistakes in this video, very lagging something, because I haven't prepared much to do this paper. Actually, I just randomly go through some questions only. So I felt like there are many laggings. So very sorry for that. I hope this video would be useful for you. And thank you. If you like this, do subscribe and share this video with your friends. And please comment whether this video is useful and you like this. Okay, thank you. See you in the next video. Thank you.